Good morning, everyone. Today we'll be starting with the AtCoder educational DP contest. Right. We'll start from the complete basic level and go to all the advanced level questions here. It's a very easy problem set. It covers mostly all the concepts. Yeah. So let's start. First, we'll take an example of printing the Fibonacci numbers. Right. The Fibonacci numbers are 0, 1, like the sum of previous two numbers 0, 1, 1, 2, 3, 5, 8, and so on, right? So we'll make a function which will use to print these numbers. Basically, we'll do cout f of n and n. So in this recurrence, what will happen is we want to return sum of previous two states. Yeah. But when should the recurrence stop? If n is less than equal to 1. Yeah, return n. Basically, so this is the basic recurrence method, recursion. It has time complexity of 2 raised power n. Yeah. Now what we'll do is we'll memoize it. Memoize it store the already calculated values, so the time complexity decreases. We'll have a vector of int of dp. Initially we are going to store it with -1. Yeah. So what we are going to do, if we have already came to this value before, right? If it is not equal to -1, that is we have already come to this value, we have already calculated this value, we are simply going to return it. That's it. And when we calculate the new value, we'll store it in this dp value. That's it. This is basic memoization method. Memoization, or also called the top-down approach, as we'll start from the top value and we'll keep on reaching till we get to the base case, and then we build up. Yeah. The time complexity here is going to be O of n. Simple. Just the thing is, we will have to use extra O of n for auxiliary stack space. Auxiliary stack space, as we have to call first the whole stack. So what better approach is, we'll use tabulation. We directly start from the base case. So how do we do that? First, yeah, let's comment this out. First we'll have dp of 0, which is equal to 0, dp of 1 is equal to 1 in tabulation here, and then we are going to start filling. Plus dp of I minus 1 plus dp of I minus 2 basic, and then we are going to return the dp of n value. That's it. This is the tabulation method. We are starting to calculate everything from the base case. This is bottom up approach. Bottom up. O of n. The thing is, what's better is, not only we don't need to use an extra auxiliary stack space, we can also track back, like we can solve many other questions because we have all the stored values in a table. And there is also one better approach, which is for like space optimization. Like, let's comment this out. Like a is equal to 0, b is equal to 1. We don't even need a dp array. Yeah, for int I is equal to 2, I is less than equal to 1, I plus plus, int c is equal to a plus b, b is equal to c, and then we are going to return the previous value, that is b. So this is space optimization. The thing, the better thing in this is just the stack space decrease to like O of 1, like we are just using two variables. Time complexity is still O of n, but the space complexity decreased to O of n, right? Yeah. So this is like basic introduction of all the methods. Like the, or you can just write, if you want to use the ternary operator to shorten it, right? If dp of n is not equal to -1, we are simply going to return dp of n. Else we are going to return dp of n is equal to what? If n is less than equal to 1, we are going to return n. Else we are going to return function of n minus 1. We can pass dp here as a second variable also. Yeah, that's it. So this is what we'll be having if you want to use ternary operators. So this was like all the basic stuff about the dynamic programming. Now let's get started. First, we'll start with this question. Frog. In this question, we are given that there are n stones numbered from 1 to n. We are given their heights. What the frog can do, it can jump to stone I plus 1 or I plus 2. And hence the cost occurred is h of I minus h of j. Yeah, so we just have to find the minimal total cost incurred before the frog reaches the stone, right? So basically, this is just the Fibonacci question, Fibonacci series in a question format, right? So let's start. Well, the main thing is just finding a recurrence, what the recurrence is going to be. Yeah. So f of I is a what? The function is minimum cost to reach what? First stone, reach ith stone from the first one. Simple as that. Yeah, so we'll just see what are the input. We have to take n as an input, and then we have to take the heights array. Simple. In n, say in n, we'll create a vector. We'll just use the vi. Yeah, we'll initially store all the values, and we'll also create a dp to store all the states. Initially we'll fill it by 1 because we have to minimize, find the minimum value, right? Then we are going to loop through all these values. We are going to take it as an input c in a of I. Yeah. And with this, dp of 0 is going to be 0. Like base case, we are going from 0th stone to 0th stone. We are going from 0th stone to 0th stone. Yeah, right. And so if like we have already, if another base case, if n is equal to 1, we have only one stone, we are simply going to see out dp of 0. Like this is just a base case, and then we are going to return. Now what we want to say is like, what will be dp of 1? We don't need to actually find it, I'm just showing it to give an example. It will be absolute of a of 1 minus a of 0, right? Like the total cost which is required to go from height 0 to height 1, right? Now to calculate the rest of the values, we are simply going to go through the loop. dp of I will be what? Minimum of either the previous state plus the difference between the height of these two states. Absolute of ai minus a of I minus 1, or dp of second last state plus absolute of a of I minus a of I minus 2. That's it. Yeah. And then we are going to simply see out dp of n minus 1, because we are doing zero-based indexing, right? So like this is a very basic question. We are going to just now submit this code. Yeah. Okay, and let's go to the next question now. Okay, we'll go to the next question now. There is compilation error. So we just have to like return 0 for success. So now we'll go to the next question, frog 2. Hope it gets submitted. Yeah, it's submitted. Now, in the next question, what we are having here, it's like we can go from ith stone to I plus 1, I plus 2, I plus 3 up to I plus k. That's the only difference in this question. So we just have to form like a loop to traverse to all those states. That's it. Yeah. We are going to take in n and k as an input. Yeah. And we are going to create a vector of int n comma 0. We are initially going to fill all those values with 0, and we are going to fill all the dp values by in like maximum value, because we are trying to minimize it, right? So let's start with this. We'll first take all the heights as an input. dp of 0, obviously it's going to be 0. Here we don't even need to calculate dp of 1 like we did in the previous question, dp of 1, right? And we don't actually need to write the base case. I just wrote for the sake of showing, so you get better idea. Now we'll go through all the value from 1 to n. 1 k plus 1. What it's this for loop is, we're going to go to all 1 up to k states, right? Yeah, that's it. And what we are going to do, if I is greater than equal to j, right? Obviously otherwise we can't reach those states. dpi of is equal to minimum of what? dp of the current I, comma dp of I minus j from the previous state, if it can reach from that previous state to here. And then what's the absolute difference between the height? Yeah, that's it, I minus j. So yeah, that's done. Now we are going to simply see out dp of n minus 1. Yeah, and L. Yeah, let's submit this code. These are like basic questions so that you get an idea. Now let's start the next question. It will get submitted hopefully. Yeah. See, vacation. This is also very easy question. In this question, Taro's summer vacation is starting tomorrow. He has decided to make plan for it now. So the vacation is of n days, right? So what Taro can do on the ith day, he can do like one of the following activities, right? So he don't want to do the same activity for the 2 or more consecutive days, right? We just have to find the maximum possible total happiness that Taro gains, basically. Yeah. So yeah. It can't do the same activity or 2 or more days, right? So if on a particular day he did some activity like A, so in the previous day or the next day he will do different activity. That's it. We'll just create a recurrence. There is not need to even create a recurrence. We'll just simply take input n, a, b, c, right? C in n, c in a, c in b, c in c. Yeah. We'll create a vector of int of dp, 3 states. The 3 states are going to be like either doing nothing, no sorry, either doing the a activity on the day or b or c, right? And then this is for the column vector, which is also going to be of the type vector, and it's going to store all the n values here. So dp of 0 0 is equal to a, right? dp of 0 0 1 is equal to b. dp of 0 2, sorry, the first dimension is for the vector. So what it's saying, if on the 0th day we did the 0th activity, we have the value as a, otherwise we have the value as b, otherwise we have the value as c. These values are just happiness. Yeah. So we can also like space optimize it, like it's very simple, but I'll just keep it simple here. What we are going from the first day to the n minus 1 day. That's 0 based indexing. What we'll do, we are simply going to take in a, b and c, right? And then what we are going to do, see, as because for each day we have to take in input values now, so it's best we take form the answer as we keep taking in the values. So dp of 0 and I at ith day is equal to what? A plus maximum of dp of 1 I minus 1, dp of 2 I minus 1. Simple. And just replace it by 1, 2, 0, 0, and I'll explain it once again. In the end, we just have to see out what is the maximum value of dp of 0 at the n minus 1 day, comma dp of 1 at the n minus 1 day, and dp of 2 at n minus 1 day. Yeah, that's it. See out until. First, let's try to submit this. Yeah. So what we did is that dp value is showing that for if we had this value at that particular day, what is the maximum previous happiness we can get, right? That's it. That's what is showing. So dp of 0 comma I means like if on the ith day we are having the 0th thing to do, then what is the maximum happiness we'll be having? Okay, sorry, it will be b. Yeah, my bad, it will be c. Okay, let's try to submit this again. Yeah. That's it. It's like a very simple question. In the end, we'll take the maximum of all three values because like on the n minus 1 day, which of the three activities we did, like which activity will give us the maximum happiness. Okay, it's still giving wrong answer. dp of I. Okay, 0, 2. What wrong answer it's getting? Array. That's okay. When we submit, we have to select the question from here. I was also like how it's getting a wrong answer. Okay, so this one is done. Yeah. Now knapsack, this is like basic knapsack. We'll go over it later. This is LCS. Okay, let's do the LCS one first. So we are given two strings S and T. We have to find the longest string that is a subsequence of S and T, right? Now here what we are given is we have to find the longest string. We don't have to like find the value of that LCS. So the standard question which generally is there is we just have to find the length of the longest common subsequence, right? So how we approach this question is that let's assume we have two strings A, B, A, X, Y, and B. Other is A, B, something, X, Z. We'll create a recurrence now first. dp of I, comma j. Yeah, just in case if you don't know, like subsequence is like some part of the array, like A, X, and B. It can be a subset, but the relative ordering should remain the same. That is the definition of subsequence. I'll write it. Subsequence is like a subset where relative ordering remains same. Yeah, that's it. Basically, dp of I comma j, what will be? Will give the length of the LIS. Length of LIS till index I in S1 and index j in second string S2. Yeah, that's it. Now, like we can generally do it using space optimization easily, but the problem is we want to print the longest string, so we can do space optimization. So here we'll be doing the tabulation method. And yeah, so what this is like when we are traversing both the both of them. Okay, so what should I do is so like when we traversing, see if a and a are equal, the ith and jth index are both equal, then we are going to go to the next index ax and ab, right? Now we are at this index, right? Now there are two possibilities. X and B are not matching, so we are going to do the two cases. Either we are going to increment X, see if we can get one answer, or we are going to increment Y. Yeah, like that. So now in the second case, X and X are matching, so we'll go to another answer like this. Yeah. another values. So this is like basic how the recurrence will happen in this. So let's start. Like these are very easy questions, so I'm just going over them. Strings S1, chain S1, S2. Yeah. Okay, so n is equal to S1 dot size, and another string m is equal to S2 dot size. Yeah. Now, see, there is one thing to keep in mind. The strings are going to be zero-based indexing, zero-based indexed. The length is going to be one-based index. So that's very important to keep in mind in these questions. So we'll just create a vector first. Vector of int of dp of n plus 1. Vector of int m plus 1 comma 0. Yeah. Now, there is one thing. Generally, if I filled whole dp table with 0, but if it was not the case, we have to, like, for base case, what we have to do is first row 0 comma j, and first column I comma 0, both should be initialized by 0, because if one string is empty, then the length of the common subsequence is obviously going to be 0. So this is the base case. I'm just saying, because by keeping the whole, or initialize the whole table by 0, we are going to have those values. Now let's start basic recurrence. I have rep value written, right? So we'll start from index 1 and we'll go till index n. Yeah. J1 m plus 1. Yeah. Okay. So you see, I already told the dp value are going to be one-based indexing. So if S1 of I minus 1 is equal to what? S2 of j minus 1. Currently, in the dp, we are having the length I comma j, but in the string, we are going to be at the position I minus 1 and j minus 1. Simply, dp of I minus j is equal to 1. What? 1 plus dp of I minus 1, j minus 1. Else what's going to happen? See, we can also write it in one line using ternary operators. I'm just writing so that it's easier for you people to understand. I minus 1 j and dp of I j minus 1. Yeah, that's it. Basic recurrence, it's done. Now what is going to be the length? Generally, if it was just tell the length, we have the answer as the length. Yeah, right. So we can just check if you want to see. Now we want to print the longest, right? So we are simply going to create a string of length answer and initialize it to empty string. Yeah. And we are going to have two variables, int I is equal to n, j is equal to what? M, right? So while both of them, I is greater than 0 and then j is greater than 0. This is just basically printing in a reverse recurrence manner. Yeah. So if you'll just make the dp table, like if you'll just write it with your hands, it will be very easy to understand. So if at the current time what we are having is s1 of I minus 1 is equal to s2 of j minus 1, right? Which means we can print any of those two values. So string of answer minus 1, answer minus is equal to s1 of I minus 1. That's it. And then we are going to decrement both I, j and answer variable. Else if we are going to see if they are unequal, from which dp, like from the row, above row, or the left side column it came. So dp of, if it came from the above row, dp of I j minus 1, we are simply going to do I minus minus. Else we are going to do j minus minus. Yeah. I think that's it mostly. Okay, so with this, I think it should work, hopefully. Okay, let's try to submit this. So basically what we are doing is we are just calculating the storing all the values in table, and along with that, okay, what it happened? Okay. Hmm. So what we're trying to do is fill on that like LCS values in the table and find the maximum answer. And using that, we create a string, and we are just traversing the DP table from the last value, because the last value is going to store what is the maximum length. And when we'll track back, see if the indexes at that point are equal, which means that DP value has come from like the previous row and the previous column. Okay, and else it we just see which of the DP is like maximum, like minimum, and we just go back to that particular value. Okay, yeah, that's it. So we are having like a runtime error or something. Yeah, okay. Just a minute. Okay, so we're having a runtime error. I is greater than 0. Okay, why are we having a runtime error here? DP of I j is equal to 1 plus DP of I plus else DP of ij is equal to minimum these two values. Why are we having that? Okay, in some questions it's getting accepted. How it's not possible? We are having int long. We're taking the string as input. We are finding their lengths. Vector of int dp n+1 right? We are going from 1 to n+1 j to m+1. If the string indexes are equal, dp of ij is equal to 1 plus dp of I minus 1 j minus 1, else dp of ij is equal to maximum. Okay, yeah, so my mistake. We're trying to find the longest. Yeah, that's it. Let's submit this. Yeah, I think this will work now. No, let's. Okay, yeah, if it start getting submitted, it will solve. So let's start. So we have done 4 questions till now. We'll start with longest path question. Okay. So we are giving a directed graph with n vertices and m edges. Vertices are numbered from 1 to n, and for each I we are having ith directed edge goes from vertex xi to yi. So it does not contain any directed cycles. So if it does not contain any directed cycles, we have to find the longest directed path in this graph. Hence, the length of the directed path is the number of edges in it. So this is like basic DFS question, like as there are no directed cycles in this question, right? So like if f of I is the maximum length, right? So what we are going to do, f of node is equal to 1 plus maximum of all the values, maximum of all the f values of its children. Simple. Whatever is the longest path of all the children, we'll just add 1 to it, and for that particular node we are going to get the longest path of it. And answer is equal to what? Answer is the maximum value of the source, or any source, like any node. Yeah, that's it. We can find for all the DP values what is the maximum longest path for that particular states, and for every state we are going to calculate the maximum of those values. So simply, first let's create a graph. If I just confuse you, my bad. Yeah, graph. Okay, we have 10 raised power 5. Okay, we don't need that extra. Simply, what you are going to do, first we are going to take in a NNM the number of nodes and number of edges, right? We are going to memset, fill this DP with -1, so we can memoize it with size of DP. Yeah, that's it. Okay, so we are just taking the input, we're taking the edges as an input, right? int x y, scene x, scene y, and then we are going to have zero based indexing in the graph, so we are going to decrement it. This is just basic graph building, minus minus y, right? Now what is going to be our answer? We want to have the longest path, so we'll put in the minimum value, that's it. And then we have to see out answer, and right, and we'll create a function which is going to help us find the longest path from that particular source. But here there's no given source, so we have to find that particular longest path value for all the vertices and just maximize it. So we'll just make a loop, and answer is equal to what? Maximum of this answer, and find what? Longest path for that particular source. Yeah, that's it. This is also yeah, if also there are more than one connected components, find longest path, and this is going to take a source, right? Now if there are more than one connected components, this is going to take care of it. So basically what we are going to do, simply first initially in answer is equal to int min. For that particular node, what is the longest path? Initially going to be int min, right? And we'll see if it's a leaf node or not, right? Number of children, initially we are assuming it to be true, that it does not have any children, there's no children of it. Number of children are 0, no children, yeah. So what we are going to do now, we are going to go to the adjacency list of that graph. If it exists, if it does not exist, then there's no issue. If it is a leaf node, simply what we are going to return 0, as there's no more path coming from the child. So what we are going to do for no children is equal to false, as we have an adjacency list for it with some children in it. So we'll just keep this boolean variable as false, and then answer is equal to what? Maximum of answer, comma 1 plus find the longest path for this child. Yeah, basic, that's it. And then we are going to return what? If no children, means if it does not have any children, we are going to return 0, else we are going to return result or answer. And so this is basic, this is like a very basic DFS question. We are going through it, the source, and what we are doing is, if it does not have any children, simply return 0, because further path is not going to get anything. If it has children, then we are going to find the maximum value of the longest path in all those children, and just we are going to add 1 to it, and then we have to just memoize it with a DP, that's it. So this is not actually a DP question, it's like basic DFS with some dynamic programming stuff. And when we are returning, we just do return DP of source. Yeah, I think this will work. Control A, Control C. So I think this will be working now. This is just basic DFS question. Yeah, I think, yeah, it's working. So let's go to the next question. Next question is grade 1. Grade 1, this is a problem where we are given horizontal rows 1. So what we have to do in this question is, we have to reach from square 1 comma 1 to square h comma w, right? So with this question, I will teach you the concept like the indexing, mostly clear the concept of indexing in DP. Like, what is the most confusing part? Like, generally what happens here in this question, we are given that there are going to be some obstacles. If there weren't any obstacles, simply what will be the answer? n-1 plus m-1 rows plus columns, c n-1, right? Okay. But there are obstacles here, and also we'll have constant int mod is equal to 1 in 9 plus 7. Right? But we are having obstacles here, so we can solve it using dynamic programming. Yeah. First, we are going to take in input int n m, like the dimensions of the graph we are going to build, vector. Like whenever these type of problems come, we should take the character vector of character. We'll make a grid of size n plus 1, but we should take the character. Yeah. m plus 1 comma 0. Yeah, that's it. And let's start. First we are basically taking in the input. This is just time pass stuff. What we're doing, in each line we are having a string s, right? This string which we are taking as an input, right? What we'll do, we'll now go through the columns m plus 1. This is one based indexing. The graph is going to be one based index. Graph of I comma j is equal to what? S of j minus 1. Because the we are making the grid or grid one based indexing, and our string is zero based indexing. So okay, we'll just call it grid basic. So this is just taking an input. We can also make it one based indexing, zero based, whatever, that doesn't actually matter. Now we'll create a DP state. See, what I'll teach here is like about indexing and other stuff. Okay, sorry for commenting it out. Vector, right, of int dp of n plus 1 and vector of int of n plus 1 comma 0, right? So what dp, see, actually we can solve the same dynamic programming question in different ways. It just depends on the meaning of the recurrence which you have formed. Like dp of n m is equal to 1. What it means here is that, like, we are starting the number of ways to the reach n mth position, this position, right? Like if we are at the nmth position, I so like if we do it like this, our answer is going to be dp of 1 comma 1. What Okay, let me explain you again. What it means is number of ways to reach this index in grid from wherever we start. So this is the meaning of the dp here, right? As we keep on going forward, you are going to understand this. I is greater than equal to 1, I minus minus. I'll write the full loop so it's a bit easier to understand. Yeah, if I is equal to n and then j is equal to m, basically we are going to continue as we have already, stored that value. Else, if that particular grid value is having an obstacle, is equal to what? An obstacle, right? So we are going to fill the dp value by 0, and then we are going to continue to the next iteration. Else, what we are going to do is dp of ij is equal to what? See, if it is in the nth row, right? If dp is in the nth row, I is equal to n, right? It's going to be 0. Else, dp of I plus 1 comma j plus, if j is equal to m, it's going to be 0 dp of I j plus 1. That's it. And simply we are going to submit this first. Like if we are okay, what's the problem? If we are at some index, right? If we are at some index 1 comma 1, the number of ways to reach, the number of ways it can reach to 2 comma 2 is either via 1 comma 2 or 2 comma 1, right? So whatever is the number of ways, so okay, so right, we are at the state 1 comma 1. The number of ways in which 1 comma 1 can reach n comma m is equal to the number of ways either it can reach 1 comma 2 plus the number of ways in which it can reach 2 comma 1. That's it. Simple as that. Okay. Okay. Waiting for judging. So like this is like basic recurrence. Yeah, that's it. There's nothing more. Compilation error. There's some compilation error somewhere. I should include this yesterday. Okay, we also have the mod value. Okay, I forgot about that. Yeah, I forgot to do the mod here and there. Yes. I think it will give TLE. So like this is a very basic question. The main point of the question is to show that okay, wrong answer. How it's going? Wrong answer. Is it wrong answer for all the values or just one two? Okay, so what we'll do is just actually we didn't do the mod na. So okay, it's a bit hectic. Hmm. So this method, this question is just to show different ways of writing the recurrence, writing the indexing. First, let's see if it gets submitted, then we'll go the other methods. Okay, what's the issue here? Okay, it's actually giving wrong answer. So let me check this again once. So first we are basically taking n and m input. We are creating a grid, right? We are taking string as an input. Grade of ij is equal to s of j minus 1. Okay, that's nice. We are creating the vector of n plus 1. We are indexing it to 0. It's equal to 1. See out dp of 1 comma 1 until I is equal to 1. It is greater than equal to 1. J minus minus. Okay, this is right. If I equal to n and then j equal to m continue, that's also good. If grid indexing is blocked, we are going to make the dp is equal to 0. Else dp is equal to what? I of I is equal to n 0. Else dp of I plus 1 comma j. Okay, so okay, this mistake we did. We have to include all of this. Okay, so this is like a very simple error, I guess. Let's hope this is the only error which is. Let's try submitting it again. So look, yeah, it gets submitted or not, that doesn't actually matter. Let's comment this out now till here. Yeah, what we are going to do, okay, so we are going to create a array of strings. I'm going to show you different methods of doing it. For int I is equal to 0, I is equal to I plus plus, in s of I. Instead of creating vector, we can just create strings if you want. Vectors actually good, but strings are like short to write. You're just creating arrays. Okay, now it gets submitted like bullshit. Huh. So where was I? Yeah. So what last time we did is we make the DP such that DP shows number of ways to reach n comma 1 in the grid, right? So we are starting from the bottom right corner. Instead, let's start from the top left corner. What we are going to do here is for first like see out dp of n minus 1 comma m minus 1. See the difference? DP, the indexing does not actually matter. Like what is bottom up, top down. The main thing is where is the base case. Like in this question, we can take any as the base case, anything as the base case. So let's start filling this up. Yeah. Okay, for n j is equal to 0, j is less than m, j plus plus. See, in the previous question, I take it as one based indexing. Here, I'm going to first do it in zero based indexing. If I is equal to 0, see, it's just like that. Here it was I is equal to n and j is equal to m. Here it's going to be this. Because if it's at that position, what's the number of ways? Is equal to 1. That's it. And else if I instead of ternary operator, I'll write it completely open. If it's in the if the ith row is equal to 0, right? If the ith index, which means dp of I comma j is equal to what? Dp of I j minus 1, right? Else if j is equal to 0, dp of I j minus 1 is equal to dp of I minus 1 j. That's it. See, we just change the order, like change the signs actually. And else, if it's not in the first row or the first column. dp of I is equal to what? Is going to be sum of those two. dp of I minus 1 j plus dp of j I minus 1. That's it. Okay, I forgot about the obstacle. We can also do it down here. If s of I j is equal to what? dp of I j is equal to 0. That's it. And then we are going to do here mod. See, with this, you can get that the indexing does not matter, like from where you are going to where, because in this question there's no like particular base case. Like whatever base case you form in any question, like if you start from there, it's tabulation method. If you start from the opposite sides, it's going to be recursion. Yeah, so this gets submitted. Okay, it's compilation error. Like what the fuck? Okay, it's the same thing like the last time. Okay, let's see. Else if I0 db of I0 is equal to. Okay, this is my bad. So with this, I think, yeah, this is done. Now it will get submitted. Now we can also do it differently. If you want to make this one based indexing, we just have to change the indexes. That's it. Nothing else. We just take it. If I is equal to 1, I is equal to this. That's it. All done. Yeah, so okay, it's still giving wrong answer. Whatever. So what we are doing, like if we change it to one based indexing, if I is equal to 1, j is equal to 1, dp of ij is equal to 1, else if I is equal to 1, dp of I j minus 1, else dp of I j minus 1, and here it's going to be okay. Yeah, so this thing we did wrong. So like yeah, that also got submitted, just like basic error. So we can see is that the indexing does not actually matter. The order in which we traverse, like the loops going where I and j, that doesn't actually matter. It's just the way in which you write the recurrence. Yeah, it will get submitted. Okay, still it's okay. I'll just see once. Okay. We are taking string s of n. We are taking input, right? In dp of n plus 1 m plus 1, I equal to 1, I less than equal to 1, j equal to 1, j less than equal to m. If I equal to 1, j equal to 1, dp of ij is equal to 1. Else if I equal to 1, this is right. dp of I minus 1j. Okay, it should work. I don't know what's the issue here. So yeah, there might be some syntax error or whatever. Generally, you get the idea, na? What's happening here. Yeah. Hmm. Okay, there's some issue here. Okay, there might be some issue. Well, we can look into that later. So overall, the idea is like basically the indexing does not matter. We can go in anyway. Yeah. So like these are the basic questions. Now let's go to the next question. Coins. Okay, one of them got submitted now, so just take care of that. Just see what the issue was in the ordering, some issue might be there. So let's start with the next question. Coins. Okay, coins. Yeah. What is given in this question? Let n be a positive odd number. There are n coins, 1 to n. For each coin, when it is tossed, it comes with heads with the probability pi and tails with the probability 1 minus pi. Tarot has tossed all the n coins. Find the probability of having more heads than tails. So we have to find the probability of more heads than tails. So instead of that, what we are going to do is f of I comma x. What this will be? Probability of getting x heads in I coins. So what we want is the probability of getting more heads than coins. So that's easy. So we'll make a recurrence such that we get x heads in I coins. So we just then find like if it's n, like n plus 1 by 2, n by 2, n plus 1 by 2 number of heads. So what this is going to depend on, if for any index I we are having x heads, right? So in the previous index, either we did not got ahead, we didn't got ahead, or we got ahead. So it's going to be f of I minus 1, x minus 1. X minus 1 is the case where we did not got ahead. X minus 1 is the case in which, okay, sorry, I'm saying the opposite. Probability of getting x heads and I coins, like if in this time we did not got ahead, or in we got ahead, right? So it's going to be into p plus f of what? I minus 1 x star what? 1 minus p. P is the probability of getting head, right? So if in the last time we had x minus 1 heads, the probability in this index we are going to have x heads, we just simply multiply it by p. If in the last time we had x heads, now we also having x heads, which means we got a tail. So that's it. And then dp of I j, we just take it, change it into I comma j. Probability of getting at least j heads in I coins. That's it. We'll create it's like 3k and its probability, so we are going to have a double, long double dp of 3k 3001, yeah, basic. So this is just the basic recurrence which is found. Okay, what's the issue here? It's like not int, sorry. So first we are going to take int n, right? Then we are going to take all the find the probability of having more heads than this. When coin I is tossed, it comes with the probability head I, right? So we are going to vector of int. Okay, we can't have int, we are going to have long double probability. See, it's like these are basic questions, all the ones which we did till now. These are like very easy questions. For int I is equal to 0, I is less than n, I plus plus, sane p of I. Okay, so each coin can be tossed with a probability pi. We just have to find the probability of having more heads than tails. It's an odd number, so there's always going to be like a particular least number of heads. Least number of heads is equal to n by 2 plus 1 or n plus 1 by 2. I think it's going to be the same thing. Yeah, so let's start here. For int I is equal to 0, I is less than equal to n, I plus plus, dp of I j, I 0 is equal to 1. What does it mean? Is that for all the coins getting 0 heads, like we can always get 0 heads, na? We didn't toss, we got 0 heads, that's it. Like at least 0 heads, the probability is always 1, because yeah, that's it, like that's simple. Now what we are going to do, is we are going to traverse from all the coins. Like if we are using the first coin, then if we are also using the second coin, and then we are going to see fill all the DP table till the least number of heads, right? Using the above recurrence. First I'll write submit, then I'll explain again. I is equal to 1, I is less than equal to n, I plus plus, for j is equal to 1, j is less than least number of heads, j plus plus. dp of ij is equal to what, right? dp of I minus 1, if using I minus 1 number of coins, how many heads we had? J minus 1, which means in this turn what we got? I minus 1, because our dp is 1 based indexes like 1 2 3 4 coin, but the probability which we are given is 0 based index. If for the first coin p of 0 will give its probability, that's it. And dp of I minus 1, using I minus 1 coins, we had j heads, so here we are going to have a tail, that is 1 minus p of I minus 1. Yeah, that's it. So I think this is like basically done. Like this is a very easy question, just basic. We have a dp and just filling it, and when we have double, we'll do fixed precision, set precision, and till where we have to set. Just fill it till 10. It doesn't exist. dp of, we have to use how many? N coins, and get how many, at least how many heads? Least number of heads, right? And thus we just have to do end L. Like sometimes we get wrong answers, like when we solve continuously while explaining while making the video. I hope it will work. Okay, the rate at which it's going, I think it's submitted. Yeah. Now let's go to sushi. Sushi will do later. How many questions we have skipped? A, B, C. We have skipped D, E. Yeah, F, G, H, I. Okay, sushi will do it later. It will take a lot of time. Yeah. So the last video I made, which actually got stopped around this point. So like I'll try to now explain nicely all these questions. Like first, when you try a question, read it, try to understand the question, attempt it, then come to the solution. Okay, I'll just take a 1 minute break. Okay. We are given a set, right? So the video is ongoing, right? Yeah. We are given a set A1 up to N, which consists of n positive integers. Tarot and Zero will play the following game against each other. Initially, we have a pile K consisting of K stones. The two players perform the following operation. Choose an element X in A and remove exactly X stones from the pile. A player loses when he becomes unable to play. Assuming that both the players play optimally, determine the winner. So this is a very easy question. Like if you have any idea of game theory, this is going to be very, very easy. And from this point on, I will explain very nicely and slowly. So this is basically a basic game theory question. Yeah. Like basically, if we are at the 0th index, right? Like 0, 1, 2, 3. If we make the opponent reach this index 0, he will lose, obviously. So if we can pick 1, 2, 3 stones, I'll just explain this with this example now you'll just understand everything. 4, 5, 6, 7, 8. Like what we can pick from the pile, we can pick either 1 stone, 2 stone, or 3 stone. Like this, assume this many stones are available. Like if we make our opponent reach the 0th position, right? Obviously we win, so this is going to be L. We don't want to reach here. And if we are at the 1 stone or the 2 stone or the 3 stone, we are obviously going to win because we can pick these stones. So from if the third stone, we can make it reach to a losing position, right? We win. That's it. Now it's the opposite. From 4, we can make it reach to 1, 2 or 3. So this is going to be a loss position. This is going to be a loss. This is going to be a loss position, right? Basic. So that's it. Like we have solved the question. So f of x, if someone starts with a pile of x stones, whether he will win it or not. That's it. F of 0 is equal to 0. If he's at 0, obviously he's going to lose. And f of any x, if we can make it reach the any of the losing position, right, then we win. That's it. If we can make the opponent reach the losing position, we will win. 1 if for any I, f of x minus ai is equal to 0. That's it. Such a simple question. So we are going to take n k, same n k, vector int a of n. That's it. For int I is equal to 0, I is less than n, I plus plus, we are going to say in a of I, and we'll create a cout stones in which we'll pass the piles. We have to pass k stones, and yeah, that's it. We have to find a and k, and this is such a easy question. I'll just right, we have k stones. So we'll just create a vector bool to store the, like, if it's a winning state or the losing state. K plus 1 because we have to fill all the k stone values, right? So what we'll do for int I is equal to 1, we'll go through all the stone values, right? And then we are going to go through all these values like 1, 2 and 3, like using all the, you can use auto int, whatever is your choice, using all the values which we can, here a denotes how many stones we can pick from that k value, right? So if with using any of those values, right? See, basically if value is greater than that particular index, we are going to continue, because like if values like we can pick 10 stones from like particular value, but currently we are at the 6 stones, means if it's like we can also pick 10 stones from this pile, but currently we are at the like when we are filling the DP array, we can only see there are like 6 possible stones. So obviously we are going to continue. Else what we are going to do, if DP of I minus val, right, if it's equal to 0, false, so that's the DP of I is equal to 2. That's it. If we can reach to a failing position, actually we are not reaching, it will be the previous stone of our opponent, he loses, then we are going to win. Simple. And simply what you are going to return in the end, DP of what, k. If it's true, then we are going to return winner or loser. First, second, yeah, then we are going to return first, else we are going to return okay, first, else we are going to return second. Yeah, I think hopefully it is going to get submitted. Yeah. Okay, like if it start executing, it will get submit. Mostly it's like syntax error when I solve some questions. Other than that, it probably gets submitted. Let's go to our question DQ. Yeah. Now this is a very nice. Okay, I hate it when this happens. So yeah, let's go to the question DQ. This is a very nice question. This is a very amazing question. So like listen very carefully. This is well, let's say the solution is very easy. Just understanding the concept is very nice. So Taro and Jiro will play the following game against each other. They're given a sequence, right? Until it becomes empty. The two players can perform the following operation alternatively. So they can either remove the element from the beginning or the end. So whatever element they remove, like that player earns that points, right? Taro tries to maximize x minus y, while Jiro tries to minimize x minus y. Assume that both play optimally. Okay. Find the result of x minus y. So basically, what they are saying is x minus y, maximize, minimize means both are trying to maximize their scores. That's it. That's what they are doing. Like you probably understood the question. So let's start here. Now, why we can't do it gradively, right? Like if you have A, B, C, D, like among A of D, which is larger? A. So let's say Taro takes the A value. Now you'll say Taro takes the A value, right? But what if B value is going to be far larger than the A value? We currently don't know that, now. So we just can't do it like a maximum of A comma D, right? So that's why greedy is going to fail. Yeah. What it actually is, this when we like extend this x minus y, let's say first he took the A value, right? Then his opponent took the B value, A minus B. What is A minus B? This x minus y value. But minus A minus B minus what? C value, which the first contender took, right? Right? You understand what I'm saying here? Minus D value, D, and so on. So if you open it up, what it is A plus C minus B minus D, or minus B plus D. So all the sum of all the values of Taro minus sum of all the values of Jiro. So initially what we want to do this. So sorry, this should be first I showed the wrong one. So like actually we are trying to do this. That's why greedy will fail, because we also have to take in mind the other values, inner values, right? Now there are two methods to solve this question. Like the most basic one is like not a 3D DP, but like DP of I J. I'll just first show it, like just for the sake of showing it. DP of I J turn, which is equal to 1, means whoever is getting turn right, will try to maximize or minimize, right? First I'll write, then you'll understand. DP of I comma j comma 1 is equal to maximum what? Like if that took the ith plus DP of I plus 1 j 0 of j DP of I. Just don't actually focus on this I'm showing just to show like the basic one approach. DP of I j 0, which is equal to minimum of yeah. So making it difficult. Yeah, so that's it basically. So DP of I comma j comma 1 it will be going to store all the values. So like this is like a very crappy approach. And dp of I j comma 1, I'll show you a better approach. This it will going to store like sum of all values of a taken by player 1. Yeah, it's something like that. I actually don't know properly. Maybe I wrote something wrong. So it's like we are doing on the basis of turn index. One is trying to minimize, other is trying to maximize. So like yeah, something like that. So actually maybe I wrote it a bit wrong. So like now I'll show you the approach, the way how I solve it. Okay. So what both actually see, one wants to maximize x minus y, right? Other wants to minimize this, or we can also say that, or we can say that other wants to maximize what? Negative of this, right? That's it. So this is like the best way to solve this. Like forget this part, my bad. I should not have mentioned that in the first place. Okay, so then what is f of I comma j? F of I comma j is the resulting value of this. We are not talking in terms of separate. We're just the maximum value of x minus y. See, now see this recurrence. If this is the value of I, या तो j plus 1 or I plus 1 comma j, meaning either we are taking the ith index or we are taking the last jth index. I'll just write, then you'll understand. Plus minus plus 1 comma j comma a of j minus f of. I'll explain nicely again. Here I up to j is the length which is left. Okay, which is left means which is we are talking about, which we want answer for, which we want maximize x minus y for. Okay, so what that depends? That depends on this inner part, right? Like this is f of 0 comma 3, 1 0 comma 3, right? Which is equal to what? A. Here a is what? Let us assume it's like this, a b c d, which means we took the first element and then we have to find whatever is the value from the rest of the array, right? Or what if we took the last element, right? Then it is going to be a of j. The length is going to decrease from the backside. Yeah, that's it. So basically that's it. It's like very easy. Like we can see like this inner value is f of I plus 1 j or f of I j minus 1. So it's not complicated to understand. It's just a bit like different. Like the other approach is a bit complicated. So I don't know actually how to do that. I was trying. So we'll leave it at that only. So we are going to have input for int I is equal to 0, I is less than n, I plus plus same a of I, right? And then we are going to make a DP here. We'll do it, pass it by reference. Yeah. We are going to like memoize it. So we are filling it with -1, and then we are going to see out whatever function will be. Now what will be the values which will be needing in the DQ? Yeah, int function, and then obviously we are going to have the starting and ending index of this length, and we are also going to pass the vector of int of ampersand a, right? Vector of int of ampersand dp. Yeah, if dp of I j is what? Not equal to -1, we are simply going to return dp of ij, and in the end what we are going to store, right? return dp of I j, which is equal to what? Maximum of a of I minus f of I plus 1 comma j. Like this is also a very easy question, sorry. Okay, f of I j minus 1. Yeah, that's it. And we just also have to pass a comma dp, and there should be a base case. What should be the base case? When length is 0. When length will be 0 if I is equal to j. So we'll simply return that particular value. Return dp of I. At this point, length equal to 1. Yeah, that's it. So this is a basic question. It's just about able to form the recurrence. Yeah, that's it. Like if you do it for the first time, it's very difficult to think. We'll start with zero-based indexing. A and dp. Hopefully it is going to get submitted. Yeah, let's try. Let's see. If it gets submitted, good. If it doesn't get submitted, then also good. Yeah, it's submitted. Now let's go to the next question, candies. It's submitted. Now let's go into the next question, candies. What you are given? We are given n children, right? Numbered from 1 to n. They have decided to share k candies among themselves. Child I must receive between 0 to ai candies. Also, no candies should be left over. Find number of ways to share candies. Modulo 10 is power 9 plus 7. First, basically, we'll just take the input first. Int n n k, scene n scene k, and then vector of int of a of n plus 1 comma 0. Obviously n is from 1 to 100, right? Yeah. For int I is equal to 1, I is less than equal to n, I plus plus, scene a of I. Right, that's it. So now what we can do here, right? In this question, we are given that a particular child I can receive between 0 to ai candies, right? Child I must receive between 0 and ai candies. Basic. Now we'll take the recurrence such that number of ways to distribute some x number of candies to I number of children. So like mostly the pattern is similar. Like if you solve lots of questions, you'll understand like mostly the way of writing it's like similar everywhere. Yeah, just a minute. So what was I saying? F of I comma j, the recurrence is equal to number of ways to distribute j candies to how many children? I children. Right. So what we are given is f of I comma j will be give us the values. Like if you are just to distribute j candies to I children, like from 1 to I, right? That's it. Now what can happen is like if like it's just that question. Which question it's coins, no coins, grid. Okay, there was some question. It's like this question, yes. So if we can reach from this state to any of the previous states, okay, I don't know which question, leave it. So like we have to distribute j candies to I children, right? Now what can happen is either like in the previous state, right? If we have how many I minus 1 children, how many candies it could have distributed? That depends on what the ith children can receive number of candies. Like if the ith children can get only 5 candies maximum, so it is only possible this value if in the previous time we have either given like j minus x number of candies. You understand what I'm saying? Okay, first I'll write it. It's like that heads question which I was doing earlier. Hmm. Yes. Okay. So number of ways to distribute j candies to I children is that if we had I minus 1 children, how many candies we had? Either if we had j candies, j minus 1 up to j minus x, because this particular child can receive how many candies? X. X is equal to what? A of j. X is equal to A of I. Right? You understand what I'm saying? Because this children can receive how many possible candies? So it's like the reverse. Initially we had this value. We can distribute how many more candies? Plus x minus 1. And this is the case when the higher children did not get any candy. Yeah, that's it. Or like if I'll say f of like if we had like base case, one children only. We have how many candies? J number of candies. The answer going to 1 if that whatever number of candies is less than equal to A of 1. Else it's going to be 0. So like basically you get the idea what I'm saying. Like 1 because whatever is the left number of candies can be given to the first children, else it's going to be 0, right? Because we don't want some leftover candies, right? Yeah, we don't want. Yeah, for those we don't, sorry, those candies are wasted, so like there are no possibilities for those candies. That's it. Now with this question, we have to do some recurrence manipulation. Like f of I comma j depends on what? F of I minus 1 comma j up to f of I minus 1 comma j minus a of I, right? That's it. And or f of what? I comma j minus 1 depends on what? F of I minus 1 j minus 1. Because the thing is already we are having two states I comma j, and if also we have to run a loop, the time complexity is going to get complicated. There are two methods to solve this. Either we manipulate the recurrence or we use prefix sum in the DP array. So for in this question, I'll do the recurrence manipulation one, and in the other one, we'll be doing it using, you know, uh, prefix sum method. Yeah, that's it. So what we can see is all this part f of I minus 1, right? It matches with this part, right? You understand? So we can just replace this part above, like from here to here, just above we can replace it. So we can write it like, f of I comma j is equal to what? F of I comma j minus 1 plus what? F of I minus 1 comma j minus f of I minus 1 comma j minus a of I minus 1. See what we did here? We reduced it so that it just depends on the, it does not depend on all these values. It just depends on the previous row. That's it. And some particular value. Initially it was depending on the previous row and so many columns. Now it just depends on this row, previous column, and the previous row, some particular, right? Or we can also say dp of ij, which is equal to what? Dp of I j minus 1 plus dp of I minus 1 j minus dp of I minus 1 j minus a of I minus 1. Right? Now this transition function, right? This is O of 1. See, because earlier it was depending on the previous row, but there are many columns here. So see how we modified the recurrence. Now it just depends on a value from this row, two values from previous column. That's it. Now we'll just create a vector of int of dp, vector of int of dp, and 101 values. 10 is for 5 vector of int of 100. That's it. And like the previous question, we are going to see out, let's say f, what's the, we need to pass the a array, exactly. We need to pass in nnk also, and we also pass need to dp array. That's it. Let's create a function. Int f will be taking the maximum candies, which will pass it by reference. Maximum candies which that particular child can take. Int n is the maximum number of children, right? Yeah. And k is the, we have to share k many candies, right? So it's going to be n int k, and then it's all going to be vector of int of dp. That's it. See, basically the point of this question, like this is very easy, like basic, but this is recurrence manipulation, and that's like very amazing thing. So like this is the base case also, we have also written there. So for int j is equal to what? J is equal to 0, j is less than equal to k, j plus plus, right? dp of 1, like if you have just one children, right, is equal to what? If j is greater than a of 1, we are going to take it to the 0, else 1. I'll explain it again, that if we have more candies left, right, then the first person index can take. Yeah. So like basically if we are left with just one person in the end, we have whatever we have distributed, we have j candies. If j is greater than a of 1, like it's going to be 0. Like we can't give 8 candies to that particular child, right? So else it's going to be 1 basic, and then we are just going to fill from 2 is less than equal to n, because we already filled for the first candidate. Stones are going to be from 0 less than equal to k plus 1. In the end, what we are going to return, cout dp of n, k, and l. We have to give k candies to n children, right? So basically if j is equal to 0, right, we don't have any candies left, so simply dp of I comma j is equal to what? dp of I minus 1 comma j. We can't give anything, right? Like, so it's going to be same value as the previous value, just with an extra children now. Else dp of I comma j is equal to what? Initially it was going to be this, a whole transition function, like in the second frog question which we did, right? Just simply it's going to be, we are having mod value, right? So I'm going to write it beforehand here. dp of I j minus 1 hash mod, right? I'll create space. dp of I minus 1 j hash mod. No, what? If this value exists, j minus a of I is greater than equal to 1, or j minus a of I is greater than equal to 1, right? Like you can then dp of I minus 1 j minus a of I minus 1, else it's going to be 0. Yeah, I'm just writing it so it's not confusing. Yeah. Okay, I think it should work good enough. So the main point of this question was to show the recurrence manipulation. Yeah, that's it. Okay, so if it starts working, it is going to get submitted. Yeah, if there is no compilation error. Okay. Okay, it's not. Okay, sorry, my bad. I spoke too early. Now let's see what's the issue. In taking the input right, vector int, yeah, this is right. I is equal to 1, I is less than equal to CNA, dp of 101, C of A N K, F, TLE. Why it's giving TLE? I think for j is equal to 0, j is less than equal to k, j plus plus. dp of 1j is equal to what? If j is greater than a of 1, it's going to be 0, else 1. I is equal to 2, I is less than equal to n, j is equal to 0, j is less than equal to k. अरे सी आउट क्या कर रहा है बहन चोद. Return. Oh, like it will just keep C outing. Yeah, that's why it's giving TLE, I guess. Yeah, so now it will get submitted. Let's go to the. Now it's giving compilation error. Okay, like when you solve a lot of questions in one go, so the accuracy obviously will decrease. It's still, the judge is still, okay, it's giving wrong answer now. Is it giving wrong answer for all? It's giving for some values only. So let's see what is the issue. If j is equal to 0, dp of I j is equal to dp of I minus 1 j, simple. Else dp of I j is equal to dp of I j minus 1 hash mod plus dp of I minus 1 j hash mod. Okay, it's going to be a minus here, right? So, okay, if I wrote the wrong recurrence, wrong dp, how is it even like 6 values getting the right answer? I never understand that. You write some shit, it somehow gives some right answers for some values. Okay, let's go to next question. Okay, how it can be wrong now? Okay, it's just wrong for one answer. What is the answer? So we can't see. So we can see, or we can't see. I think it's with some mod issues. Like if I'll just add a mod value, because sometimes it can go negative, right? So whenever we are doing mod, if I just add a mod value, it will start working. No, I'm like mostly sure it is going to get accepted. Yeah, all done. So let's go to the next question now. It's going to be, what's the next question? Candies. It's in slimes. Slimes, okay, we are given n slimes lining up in a row. Initially, the ith slime from the left has the size a of I. We have to combine the slime. The cost incurred is x plus y if we try to combine two slimes. Okay, let's go to the next question. Slimes. See, basically, I'll just keep on. How much time has already passed? It has been 1 hour 30 minutes. Okay. So, A, B, C, D. Like, basically, in the end result is obviously going to be A plus B plus C plus D, right? So, we just start from the reverse here. Because if we do it like this, where should we do a partition DP? A, B, like C, D. Like, that's going to cause problem. Because we don't know, like, where to partition from the start. So, we start from the reverse. Like it's much easier because we know now 100% that in the end it's going to be A plus B plus C plus D. Now let's like it can come from how many places? Yeah, like this, or A plus what? B plus C plus D. Like, or A plus B plus C plus D. Like this is the only three partitions for the last, right? Right. And what will be the cost here? cost equal to initial cost of first part plus initial cost of the second part plus total cost required to add them up. Or I'll say that if we have A, B, C, D, E, F at the second last step, right? I'm taking this example extended version. Now when we'll combine them, f of ABC will give us the cost to form ABC plus f of DEF will give us the cost to form DEF plus A plus B plus C plus D plus E plus F. That's it. And yeah, that's it. So just we'll find f of I comma j. Like if you have a partition, like I is here and j is here. Partition is can be from like between I and j obviously, which is equal to what? F of I comma k plus f of k plus 1 comma j. That's it. Plus sum from I to j for all k in I j minus 1. That's it. In j minus 1 because here it's k plus 1 to j na? So that's the recurrence. So basically you get the idea na? We just have to start from the reverse end. We partition from the reverse. We don't add them up one by one. We think we have a final block and how that final block was made. So yeah, but okay, so the issue here is this sum of I comma j. So it's like a basic technique if you want, like I'll show you two methods for it. First, let's solve the question. Yeah. Int NCN vector of int of a of n plus 1 comma 0, right? We are going to take an input for int I is equal to 1, I is less than equal to n, I plus plus sin a of I. This method is to store the sum from I to j, right? Equal to 1, j is less than equal to, yeah. Sum of ij is equal to what? That jth value of j plus if I is equal to j, right? Okay. Like this, just it's going to be 0, right? Else sum of I j minus 1. This is just we are trying to store the, it's kind of like storing the prefix sum, but for a particular range I to j. Yeah, that's it. I didn't create something sum. Okay, let's create a vector of int of dp of n plus 1, vector of int n plus 1. We'll store minus 1 for it, and we'll create a sum also of size n plus 1, vector of int n plus 1. It should be initialized at 0. This sum, what it will store all the values, the sum from index I to j, right? So like this is like basically just writing it. Okay, I think I missed something here. Now int f, int index I, it will need index j, and we are going to need a, we can also make this sum global. Yeah, we can also pass it. It doesn't actually matter. We have macros. No, we don't have macros, so I'll just write it. Vector int of a, vector of int of ampersand dp, vector of int of ampersand sum. Yeah, if I is equal to j. Okay, what's the error here? Okay, if I equal to j, return 0, base case, obviously. Like we are at that particular index. Else what we are going to do, int answer is equal to minus minimum int min or 1e int max 118, right? So we are simply going to return answer, right? For int k is equal to I, k is less than j, k plus plus, we are going to make partition. Answer is equal to what? We have to minimize or maximize the value. Minimize, na, right? Minimum of answer, comma what? Function of like a I comma k comma a comma dp comma sum plus function of k plus 1 comma j. We are just making partitions, right? Simple. Sum plus sum of I to j. That's it. And we are going to store it in dp. If dp of I j is not equal to -1, we are simply going to return dp of I j. Else when we return, we are simply going to store the value. Yeah, it will work, hopefully. Okay, I'll try to submit it. If you don't want the prefix sum, if you don't want, okay, I don't know. If you don't want this method, you can also do it using prefix sums. Just make basic prefix sums, right? And then use like how we do in segment trees. Like int sum from range L to R, like return prefix of R minus, if L is equal to 0, we are going to return 0, else we are going to return prefix of L minus 1. Yeah, this was also an easy question. Let's hope it gets submitted. Yeah. Okay, it's giving a wrong answer. Let's check why. So we have written this we have written right, exactly. We have took in right input, one based indexing. That's also good. Sum of, okay, because we are now not calling the function. 1 comma n and a comma dp comma sum. Yeah. And control S, control A, control C. Let's try submitting it again. Let's hope this time it will get submitted and slimes. Okay, now like O, P, Q, R, S, T. Okay, lots of questions are still there. Okay, so this one gets submitted, right? Let's go to how many questions left? Knapsacks are easy. Sushi, it's easy. It's probability based, so we'll do it later. Now we have matching left. Matching is DP based. DP with, I think, Bitmasking. Yeah, it's also a very easy question. We'll go into it after some time. What independent set? Yeah. So this is an easy question. So first, let's start with this, right? Independent set problem. We are given a tree with n vertices, right? Numbered from 1 to n. Ith vertex edge connects vertex xi to ai. Taro has decided to paint each vertex in white or black. Here it's not allowed to paint two adjacent vertex both in black. So find the number of ways. So this is a very easy question, like 1a9 plus 7. Basically, if the node is white, then its adjacent node can be white or black. If it is black, then we can only paint it in white. If node is white, we have to paint its children in either black or white. See, I'm writing this because in this question, like, it's this much only. If it's a nigga, huh, we can only paint its children white. Okay. So yeah, that's it. So what will be the answer? Like it will be the product of all the DP values of the children if u comma 1. If node comma 1 is equal to what? Pi of DP of u comma 0 plus DP of u comma 1. Sorry, I wrote both of them as u. So basically, if our this node is white, then whatever value we get of its children, like if for a children see all the black values, all the white values, whatever DP values we get, we just multiply the product of all those children values. That's it. Because for a particular node, like let's say 1 is connected to 2, comma 3, comma 4, and they have further subtrees. If 1 can be painted in white, then 2 can be black or white. Similarly, 3, 4. And what is the total number of ways in which the vertices can be painted is the product of all three, like basic PNC. But for a particular node, it can be white or black. So the sum of those ways. And similarly for DP of 0, this it will be pi of simply they all have to be white. Yeah. So that's it. Let's solve this question. We have to take an input. So just make a global graph vector of int of adjacency of how much it's 10 raised by 5. 1, 2, 3, 4, 1. And we'll make a vector of int dp of 1, 2, 3, 4, 1. Vector of int of 2, comma 1. That's it. Initially, we are filling everything by 1. That's it. So let's make the tree. We have n, so it's a tree, right? So n minus n edges will be there. So for int I is equal to 0 and a comma b, we'll just write it here like teaching something different. I is less than what? N minus n, I plus plus, because n minus 1 edges, so we'll go to n minus 2 iterations only. Scene A, scene B, minus minus A, minus minus B. I'm trying to just like complicate it, like so it's like the person can learn a bit. We are trying to make it using this. We are making it zero-based indexing. We just initialize A and B here. Yeah. B dot pushback A. We'll just pre-compute all the values, and that's it. So we'll make a DFS to pre-compute, and then we'll see out what DP of 0, 0 plus DP of, if that source node is painted with black, let's say hash mod. Yeah. So that's it. We just have to create the DFS function now. Okay, we are just pre-computing the values, right? Because so initially the node is going to be equal to 0 and its parent is equal to minus 1. Like this is basic DFS. This is just graph theory. Now we'll go to all the children in the adjacency list. And what we are going to see here, if the child is not equal to parent, obviously, like this is a basic condition, then we are again going to make another DFS, right? And child common node. That's why you store the one value, right? Number of ways in which it can be painted. Obviously, if it's single vertex, it can be painted at how many ways? Just a minute. First, I'll write it. The DP of a node, right, at particular index 0 is equal to how much? DP of that particular node 0 star DP of that particular child into 1 here. DP of a node, if it is painted white. Yeah. DP of node 1 star. DP of what? Either the child can be painted 1 or the child can be painted 0. Hash mod double mods done. Okay, so what this is like, DP of a particular instance is basically we stored everything with 1. Obviously, either it is, for the case if it is painted black, value is going to be 1. If it is painted white, it is also going to be 1. This is just that if even if it is there is one node, there's one way to paint it. This is like the base case. Then using this, we keep on adding the values. Yeah, so that's it. So this was a very easy question comparatively. Now we are going to be going in the domain of like very good questions. Like actually like very good questions. So this is flowers. In the last video which I made, which actually like stopped after some point, I did it using like upper bound, lower bound methods. Now like I have a better approach. Like you can also do it using segment trees. First, I'll explain you the problem. So this is the structure of segment tree, right? First, I'll give a brief introduction about the segment tree. Segment tree is just used to calculate like prefix sums in log of n. I think, yeah, log of n, right? So they are like very amazing. It's just manipulation of array. Like we are storing values in arrays such that it's easier to compute. Like binary index trees are also there. Also, yeah. So let's start. So basically, this is a structure. Best is to create a structure. Now there are only 3 operations: build, update, and query. This is just when initializing. Generally, we take it 4 star n because this is the maximum it can reach. In this question, we are going to initialize it with 0 because we don't need to build anything. See, if you don't have any prior knowledge of segment tree, you can skip this question. Yeah. Like the other approach, you can find it in my GitHub. Like it will be there. So this is like basically a build function. Like we are building. Like just study about it. Like this is for update and this is query. And these like basic, these are going to call the above functions, right? So yeah, okay. Query is going to give the sum of the sum or whatever thing we want in a particular range L to R. Update is going to update that range L to R. Yeah. So basically, let's say this question first. Okay. What we are given in this question is we are given n flowers. They are arranged in a row, right? The height and the beauty of the ith flower from the left is hi and ai. No, these are very good questions. Yeah. There are n flowers arranged in a row. For each I, the height and beauty we are given. So let's start here. So let's take an example. Whatever is given, we'll take that one only. Right. What we want to do, tarot is pulling out some flowers so that the following condition is met, that the height of the remaining flowers are monotonically increasing from left to right. Find the maximum possible sum of the beauty of the remaining flowers. So in one way, we just have to find the longest increasing subsequence. That's it. But there is one issue. Due to constraint, we can't do it in n square. We just have to do n log n. We have to find the longest increasing subsequence in n log n. And it's not just that thing. There's one more constraint here, that the it should be monotonically increasing, height from the left to right. Yes. Yeah. Okay. So it should be such that uh, 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 I'll just write it like that's the best way to explain it here. So there will also be notes available. What we want actually is that of all the sorry, we actually don't want the longest increasing subsequence. It's like a longest increasing subsequence problem. What we want is a subsequence which will give us the maximum beauty, not the longest, right? So of all the increasing subsequences which will give us the maximum beauty, yeah, dp of I, what, maximum beauty of subsequence from 0 to I, right? And what we are going to see for all the previous indexes, for all j which is less than I, if they are smaller, right, then only we'll try to what, maximize the current dp of I value, right, using dp of j, right, plus a of I. That's it. Simple. This is what we want to do. Generally this will go in, I think, n log n or something. I don't properly know. N square, yes, it will go in n square, close to n square, n into n plus 1 by 2. But we want a n log n solution. So for that, what we are going to do is use segmentary, right? But see, for like we are trying to maximize the beauty now. So like just in case you didn't understood that, maybe I went a bit fast. For all the previous indexes, we'll see which are height is smaller so that it can form a monotonically increasing subsequence. You're trying to maximize the beauty value using that beauty value of the older value plus its current beauty value. Yeah. So like for segmentary, I'll just make it capital. For segmentary, finding maximum of range is not an issue. That's the catch here. But how we find only for those indexes, right, where h of I is greater than h of j. So what we are going to do? So we will solve it in increasing order of heights. Yes. See, that's like the very amazing thing in this question. Like from here, like very good quality questions are starting. From Q, all the questions below are like very amazing. So what we'll do? Also, we don't need to build the segment tree. Okay. As initially everything is filled with 0. Like constructor, this constructor is filling everything with 0. We just query and update. That's it. See, so like let's start. See, without segment tree, it's a bit complicated using lower bound and upper bound. Int h of maybe if I get time at the end of the video, I'll explain the lower bound approach. Yeah, for int 0 I is obviously I have time if I'm now not brain dead till the end of the video. We'll make it 0 based indexing. It doesn't actually matter, yeah. Or we can just make the index array 1 n plus 1. It doesn't even matter at all how. So yeah. We're going to initialize the tree for int so we are going to all the heights in the increasing order, right? we find the index of that height, right? And then we are going to first update its values using all the smaller heights. We'll tree dot query from where 0 to index minus 1. That's it. Index. In the tree, we have initialized all the values with 0, right? That's it. And then we are going to update tree dot update index dp of index. And then we are just going to run a query. Okay, so basically, yeah, that's it. Yeah, it will work, hopefully. Yeah, it will work. So this was a catch here only. Like if you have done segment trees, then it's very easy that we have to see for all the heights which are lesser than j. Then we are going to go in the increasing order of heights. Yeah, it gets okay. It should get submitted. Yes, it got submitted. Very nice. So where are we now? How many questions have we skipped? How many questions have we done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have done 13 questions now. Okay, we have skipped O also. Yeah. Before we do, see this question. Okay, this is a very easy question. First, I'll do this. Then I'll finish the old ones first. Yeah. So in this question, it's easy. We just have to find some of all the smaller heights because only those are filled till that index. So that's it. Let's start with the R question. Walk. It has been around how much time? Okay, close to 2 hours. Nice. Hope in 3 hours, 3.5 hours. Okay. So in this question, what we are given a simple directed graph G with n vertices, 1 to n. For each I and j, you are given an integer ij that represents whether there is a directed edge from vertex I to j. If a of I j is equal to 1, there is a directed edge from this, otherwise it's not a 0. Okay, so we just have to find number of different directed paths of length k. We can also count a path that traverses the same as multiple times. So basically, it's like a cycle question. Like it's a very standard question. It like I'll tell you about the brief of this. It is just an like use of binary exponentiation, fast binary exponentiation. That's it in this question. That's it. Like yeah, there's nothing like hi-fi in this question. It's that much only. Here we can have cycle as a path, right? Right. For paths of length 1, number of edges equal to what? Equal to values of 1 in the matrix. That's it. That is matrix of I j is equal to 1. That's it. Well, this is only the like whatever values are there in the matrix, right? A of I j is equal to 1. These are the only like single vertices. So if we had the value of k equal to 1, what we do is just calculate sum of all the vertices which are present there. Now, for length 2, what will happen? Length 2. We need like x to y to z. But it should be such that there should be a path between x to y and y to z. Like we have to go from x to z via an intermediate node y. So we'll create another matrix. No, will not. So no, this is another matrix whose row, whose column. How we'll get whose column? Using sum of all the values. X is equal to 1 up to n w1 u comma x star a of x comma v. Just matrix multiply. I'll explain it once. what we are saying is, okay, how would I explain this? Best is to show graphically, of course. 1, 2, 3. 1, 2, 3. So if it is 0, which means there is no edge here, right? If it is 1, if it is 0, whatever are the values. Now let's create another copy of this. We'll create the same matrix again, 1, 2, 3, but this time 2, 3 will fill this 0, 1. I'll explain you what I'm saying. This is basically the initial matrix which we are given. Like taking an example is the best thing which we can do. Okay, so yeah. Yeah, next time I should use a drawing pad or something like that. Okay, so it's done, right? So if there is an edge from 1 to 1, it's going to be 0. If there's an edge from 1 to 2, it's going to be 1. If you want to find the lengths of all the parts of one length, just find all these values, like sum of all the columns, all the values, 1, 1, 1, 1, 1, 5. Answer. Now what we do for this, if you want to find the number of edges from what? We have to find another matrix with same rows and index columns, just storing the two length paths value. So w of, let's say 1 comma 3, it will be what? W, what is the path from 1 to 1 into what is the path from 1 to 3, right? Plus what is the path from 1 to 2 and what is the path from 2 to 3, plus W of what is the path from 1 to 3. That's it. We are just multiplying a matrix by itself. You just have to see that. That's it. So this is just basically the question. So to get the matrix which is storing the values of k lengths, we just have to do that particular matrix raised power k. That's it. If we do using fast and value can be up to 10 raised power 18, right? Length of k and n is 50, right? So we have the dimension as 50 star 50. K is equal to what? 10 raised power 18. Using fast matrix exponentiation, we can get time complexity of n cube, yeah, star log k, and that is going to easily pass. So we just have to take in values and find the kth power of that matrix. So this is not actually a DP question. It's like, yeah, you get the idea. Okay, for int nk, we'll just simply create a matrix VVI. Okay, I have to write many times. Yeah, it's there. VVI matrix of. From this you'll learn two things: binary matrix exponentiation and also like basic multiplication, whatever. So let's start. For int I equal to 0, I is less than n, I plus plus. For int j is equal to 0, j is less than n, J++. We are simply going to input all the values, right? And then we are going to another create an answer matrix, or let's say a result matrix, which is going to calculate the matrix power of this matrix raised to power k. That's it. And then we just want the sum of all the values in the matrix, because this matrix is already storing which nodes are having kth path, like lengths of paths of length k. So we'll do the same for I is equal to less I plus plus, for int j is equal to n, j less than n, j plus plus, and answer is equal to what? Result of I comma j. We'll just add the value. Answer plus equal to result of this. I think there is also going to be mod. Yeah, so we'll just answer hash mod. That's it, and just we are going to have to see out answer. And now just we have to write the power function, like which is going to calculate the, okay, we don't have any mod here. Okay, we have mod. And mod which is equal to 1e9 plus 7. Okay, so now we just have to create the power function. What this, it's going to return a matrix. So power, it is going to take VVI ampersand a int exponentiation, whatever we want to raise. So this is just binary exponentiation. Int n is equal to what? A dot size. Obviously it's a square matrix. If it's not a square matrix, then that would have been very complicated. Not this question, but generally the same. And v of I, n comma 0. This is like basic template now. We just have to return result. And then we also have to create a multiply function now. So first we are going to create it into a identity. We are going to create an identity matrix. Yeah, this is very important. This is like basic, like template stuff. Don't worry about that. Identity matrix, like when you'll study matrix multiplication. So we'll create another base matrix. Let's call it equal to a. Now we'll keep on doing exponential greater than 0. This is just binary exponentiation in matrix form. If exponent is odd, right? So we multiplied the result. Multiply. Okay, there is no multiply function here. Result with a base. Else what we are going to do? Base is equal to what? Multiply base comma base and exponentiation by divided equal to 2. Just study binary exponentiation. It's very easy. Now we have to create a multiply function. It's just doing the same thing for the matrix. It's nothing hi-fi. Okay, VB I ampersand b int n is equal to same procedure as below. We just have to VBI of result n comma VI of n comma 0 0 0 return result. Now we'll just multiply. We just have to go through each row and each column. This is just basic multiplication, how it's there. J plus plus. Result of ij is equal to what? Result of ij plus what? We have 10 raised power 18, 10 raised power 9 plus 7. We have to multiply two values, a of I comma k star b of k l. One second, this is a storing value. Okay, see, k is up to 10 raised power 18, right? So if we multiply it here, we should add 1 ll j hash mod. Yeah. So this is just the multiply function. This is just the power function, multiply. and we are just calculating the k power of a matrix. So basically this question, like, it's not that difficult. It was just about matrix exponentiation. Let's see if it will get submitted. Okay, like I'll do till permutation. Yeah, like I'll try to do like 20 questions. 6 ones which are going to be difficult are going to be for the next video. Digit sum, will get to learn about digit sum here. Permutation, I actually don't remember what was in permutation. Okay, permutation is a very good question. Digit sum is, you'll get to know about digit DP. Matching, here you'll learn about DP with bit masking. And okay, let's do the knapsacks ones first. Yeah, they're like very easy, so I'll just finish them first. I'll do like space optimization and knapsacks, so you'll get to know something different. Hmm. Okay, these are like basic knapsack. The first one is very easy, like basic knapsack. Everyone has done this question. Like there are n items. The second part is actually interesting. There are n items numbered from 1 to n. For each I from 1 to n, item I has a weight wi and a value vi, right? Tara decide to choose some of the n items and carry them home in a knapsack. The capacity of knapsack is w, which means the sum of the weights items taken must be at most w. Find the maximum possible sum of the value of the items that Tyro takes home. So basically, this is just basic knapsack, right? F of I comma j, right? Maximum profit and value we can get with, not with, till ith item with largest weight j. That's it. So it's a very easy question. Generally, it's like, mhm. I'll just solve it using space optimization. Like you can just look it up. So int, it's a very easy question. I'll just show you the space optimization method how to solve this. Like we don't need to store each and every like full DP like n cross w. We'll just create two DP arrays. Right. First we'll have a value n comma 0, which will store the value of each of these items, and then we are going to have a weight, of course, and dp1 having w plus 1 0, and dp2 w plus 1. First row, like, yeah, first row is already filled with 0. Like we are going to take input of the weight and value of the first indexes. That's it. And then in the end we are going to what see out. I think the previous row, yeah, like if you have done space optimization, this is the previous row, this is the current row. We just see out the value of the previous row. Now I'll just like fast forward, like it has actually been a lot of time now. DP of I0, so rep J, I think we have to swap them here. So rep J1 W plus 1, right? So I is for how many objects we can use in DP, right? J is the capacity of knapsack, right? If some weight comes, right? If some weight it's greater than J, obviously we are not going to take that. So the dp value of the current row is going to be same as the dp value of the previous row, like obviously. Yeah, else what you're going to do, if we can take it, so it's not necessary we are going to take it, right? It's going to be the maximum value of either that dp of value, or if we don't take it, of course, or the value, current value at that particular row plus dp1 of what, j minus weight of I. Okay, and then we are just going to clear the previous one. We are going to swap, yes, dp2 dot swap dp1, and then we are going to do dp2 dot clear, like the current one we are going to clear. Now let's see if it gets submitted. Okay. Yeah, it gets yeah. So this is like the basic one. Now the second version of this question, which is like the actually the which is the good one question, which is actually the interesting one. See, like this is a basic we created what, in this one we created a dp of weight and number of indexes, right? This one is, it's a bit different one. Let's see here, like when we see like w is up to 10 raised power 9, so we can't create like a dp based on w, so we have to switch it. We have to create dp based on current indices and the value, right? So it's okay, this is kinda like subset some problem, like a value j can be found using I indexes, right? Weight is 10 raised power 9, so n star w is obviously not going to work, but value is less than equal to 10 raised power 3, unlike the previous question, right? So f of I comma v, like that's it. The second question is actually very nice. It gives the minimum weight, see, so that the value of selected items is v till ith element. Okay, f of I comma v is equal to what, right? If value of that particular element is greater than the value which we can have till that, you know, iteration in dp, so simply going to be f of n minus 1 comma v, just like that. Else minimum of what, f of I minus 1 comma v, or whatever weight is we can get with that value plus, yeah, this one is a bit complicated actually. So my bad if you don't understand it. This one you'll obviously understand after a bit practice. Yeah, I think there is going to be one more bracket. Yes. So like this is not pick, this is pick. What it's doing is, like if we can get, if we, like if while filling the dp, if the value, right, of I, whatever ith element value, it is greater than the current values which we can have, right? We can only have a set of values, so it's a bit complicated to understand, my bad. Like we can only have like 10 values till now, so we are doing the reverse. If that current element will have weight x and a value 20, we can't take that element. But if we can take that element, right, then we have to see which is better. If we don't take that element, like that value is already from the previous row, or we take that element and add that weight to a previous row, some different column value. Okay, so in the end, what will be the answer? That's the best part. Answer will be for I is equal to n minus 1. That is last row. Maximum value of column J profit. Okay, such that dp of n minus 1 comma j is less than equal to w. Like, this is a very amazing question, like actually a really amazing question. Yeah, so in the last one we'll go, like dp of n minus 1 comma j will try to find the maximum j, like the maximum value which can be formed such that its weight is less than equal to w. That's it. Now I'll just solve it using space optimization. I think it's like same as before. In NW, C in NW. Last time, yeah. Okay. So vector of, like, it's going to be exactly the same. Just n comma 0. We can just copy or write. That doesn't actually matter. dp1 of n star 1 e3 plus 1. Like, if you assume that all these indexes are going to have this value only in 1e18, right? Yeah. Yeah. This 1e18 is infinity value which is stored in that index. This is for the size. Like the maximum value which you can have if all these have 10 raised power 3 values. Yeah, that's it. So we are just going to take an input. So dp of 1 is equal to what? dp1 of 0 is equal to 0, right? I think the first row is going to be 0. Yeah, except, yeah. In the first row, if we can, whatever is the value of that element, right? Value of 0, that will going to store 0. Yeah. Hmm. Hmm. That's it. So I'm actually a bit tired, but we have to do it. So what it's storing, this is the first row, and this index which is storing value of 0, it is going to have weight of 0. Of course, we can get that value using this weight. Then we are going to form two loops. If value of I which is greater than j, so dp of 2 comma j is equal to what? dp of 1 j. It's just like the previous question. Else dp of 2 of j is equal to what? Minimum of dp of 2 of j comma weight of I plus dp of 1 of j minus value of I. And then we are going to swap just we are going to clear and swap d2 dot dp2 dot swap dp1 dp2 dot clear, and we just have to find the maximum values. For I is equal to 0, I is less than what? N star for because we have to find the maximum value, right? This is necessary, yeah. If dp1 of I is less than equal to what? W. Answer is equal to I, and then we are simply going to see out this answer and L. Okay, we should also initialize answer, which is equal to what? 0. Yeah, so yeah. This is actually a good question. Like, this is like the second variation is very nice. I did using space optimization, like, so you get to learn something different. Okay, we are having wrong answer, so we did some mistake. 1e3 dp1 dp2 we took, dp1 of 0 is equal to 0, I is equal to 1 up to n, j0, 1e3 plus 1. If value of I is greater than j, so dp of 2 j is equal to dp of 1 comma j, else dp of 2 j is equal to, okay, I think yes, I missed here, dp of 1 of j. Yes, let's try submitting now. Okay, so now which question we skipped here? Sushi. Let's go to sushi. After sushi, I have to do matching, digit sum, and permutation. Yeah. So four questions are left. Yeah, yeah. Let's do this. I'm also a bit tired actually. So this is just more than a DP question. Like, well, it's a DP question. It's just you have to know a bit about probability and stuff. Not actually know about probability, just like basic knowledge of expected number of operation. So we are given n dishes, right? And initially each dish has AI number of sushis 1, 2, 3. Taro will perform the following operation until all of the sushis are eaten. Roll a dice which has equal probability. Let I be the outcome. If there are some pieces of sushi on dish I, eat one of them. If there is nothing, do nothing. Find the expected number of times the operation is performed before all the pieces of sushi are eaten. So n, a of n comma this is the input. Yeah. Okay, okay, okay. So what we are going to do? See, if we create n like NDP states, like it's going to be like a very complicated. So instead of like dishes, we create DP on sushi. That's like common sense. So okay, so let me give a brief idea about expected number. Its expected number is what? I will like let's go a bit into maths. Expectation summation probability of all events star event itself, right? Like if we toss dice, like what will be the expectation? Probability of all the events, like it is going to be 1 by 6 star that event plus 1 by 6 star 2 and so on up to 1 by 6 star 6. So that will be equal to, I guess, 3.5 or something. So like that. So this is just the expectation. Now we can't have like NDB states, right? So instead we are going to work on what? DP of I, J and K, right? I, J, K, and that's it. Just a minute. So first we'll define some terms, right? Probability of I. Yes. So probability of I is equal to what? Like X, like I by total number of outcomes, right? So dp of I, j and k. I, j and k is for like 1 sushi, 2 sushi and 3 sushi, right? Let's go. Expected value to reach the state with I number of 1 sushi. We don't need to actually have all the three, like 0, 1, 2, 3. We can actually eliminate one, like 0th number of sushi, because you know that sum is always going to be equal to n, right? Okay, I'm actually starting to slow down a bit. Like it has been a lot of time. It's now 3:45 a.m. So let's go. Now what we have to do is I'll start with the basic, right? Initially, we have a state 1, right? Right? S of 0, S of 1, S of 2. This is our current state, right? If we go from this state, like what are the possibilities? Like if we go to a dish with 0 sushi, it's going to be remaining at the same place. Let's call this state 2, S1, S2, S3. But to reach this state, right, we need to have some, probability, right? What's the probability? P of 0, or currently we can say it as S of 0 by n. See, you understand? To reach from this state to this state, first state to second state, we just have to eat nothing. And let's call another state 3. Just 2, 3 is not multiplying or anything, it's just normally. To reach to another state, S1 by n, what we do? Like the count of 0 sushi is going to increase because we ate the sushi with one count, S2, S3. Similarly, another state 4, S2 by n, right? S0 count is going to remain same. S1 is going to increase because we ate a sushi from a plate with 2 sushis. And S3, yes. And then S3 by n, S0, S1, S2 plus 1, S3 minus 1. Yes. Okay. What we can say is the state 1 and 2 are exactly same. If you just take it to the left, it's going to remain same. And we like P of I is equal to what, by the way? S of I by n, right? But when we see about expected number of turns, right? E of 1 is equal to what? Expected number of turns from this state is equal to, you can say P of 0 star 1 plus E of 2. Because to go from state 1 to state 2, we are also using one turn. Na? Similarly, like rest of the terms, right? But E2 is equal to E1, that they are the same states. So when we do a bit of manipulation, right, what we'll get, E of 1 is equal to what? It's what? Okay, it's P of 1, right? Star 1 plus E3, right? Plus P of 2, 1 plus E4 plus P3 star 1 plus E5, right? Divided by 1 minus P of 0. That's it. So this is just the equation which we get here. Now the optimization here is that first we take 3 states instead of 4, because the 0, like 0 is always equal to 0 plus I plus j plus k is always equal to n, like the dishes with having 0 sushis in it. So mostly that's it. So like we have done everything. So this is the recurrence which you can say. So let's create an array, and we are dealing with probability, so I have to use double, long double or something like that. dp of 301 301 301, right? Basically we need to have count of 0 1 and 2. Let's call it c1, which is equal to 0. Let's call it capital C1, which is equal to 0, capital C2, which is equal to 0, capital C3, which is equal to 0, Cn of n, right? And we are just we have wrap written, right? And we are just going to take in values. As we take in input, we are just going to increment, right? Int x Cn x C1 plus equal to what? If that x is equal to 1, right? Okay, sorry. Similarly, we have the count now, right? And we just form all the values one by one. Now there is one more catch in this question, like it's a very amazing thing, like the order of the loops. Yes. So what should I'll write here? Like the order in which we should write the loop, we have to make sure that loop for 3 is outside then 2. Okay, right? 2 is 2 then 2, so like that. Okay, and 2 as each state क्या होता है, like it depends on more sushi to be eaten, obviously depends on more sushi to be eaten. Thus will first finish one state, thus like the inner loop, thus will first finish once one first, then for all 2s, right, then 3s. Okay, so like how to show it is like if we have a state this dp of what, x y y, right? It can get changed into what, like if we used dp x y plus 1 y minus 1. See, so we have to like calculate the later dimensions first, like the inner dimension is going to depend on the later dimensions, so we have to calculate that first. Yeah. Okay, so yeah, you get the idea, na, what I'm trying to say. Like try to make the find the dp values. Like first we have to calculate the outer values, like the inner values, then only we can go for the outer values. Okay, so basically we are going to have 3 loops, c3, c0 and c1. First is going to be c3 is equal to 0, c3 less than equal to what, c3 plus plus. Right. Now, like for the inner loops, we don't need to go to all the C2 values, right? They only will go up to n, right? C2 is less than equal to what? N, C2 plus plus. We don't need to calculate for all the values, right? Because they can't go more than this, right? C1, 0, 0. like, because simply the outer value can only decrease, like the inner value can increase. So you understand why we are doing ordering in this, like loops in this order. Okay, so what we have to do, we don't need to actually calculate like third dimension for this. We'll just have n minus c1 minus c2 minus c3, right? So if c1, we also will do one more base case or optimization, you can say. If this sum is greater than n, we don't need to calculate the dp value. We can calculate, but we don't need to, right? So we are saving time. If also c0 is equal to n, we are going to stop at that time. dp of c1, dp of c2, dp of c3, which is equal to 0, and then we are simply going to continue. Like all the dishes have become this, right? And like, let's do it. Double p1, which is equal to how much? 1 0 star c1 by n, and p2 is equal to 1 star. So this one we multiply to convert it into our double c3 by n, right? Now what is double d3 is equal to, if c3 is greater than 0, then dp of c1 c2 plus 1. See, the outer value is already decreasing, that's why we have to calculate it first. Okay, all saying for a given c0 c1 c2, like c3 is always going to be decreasing, right? Always decreasing. So we put it in outer loop. Similarly for see, that's why you understand the order of loops now, right? If c2 is greater than 0, obviously if we can take something, dp of c1 plus 1, c2 minus 1, and c3, yeah, and it's 0, and obviously double d3. Also, yeah, I actually forgot, probability of 0 is also going to be there. 1 dot star c0 by n. Yeah, d3 is equal to how much? c1 is greater than 0, dp of c1 minus 1. Yeah, we don't have to worry about, c0. That's it. So okay, so we have all calculated all these values. Now you will use this expression. So okay, so dp of what? c1 c2 c3 is equal to 1 plus d1 star p1 plus d2 star p2 plus d3 star p3 divided by 1 minus how much? p0. That's it. And when we stop, like, okay, what's the wrong issue here? Yeah. And when we reach such that c1 is equal to c1, like we have reached this instance, right? Because we want to actually reach this state only, c2, and then c3 is equal to c3, right? Cout set precision 10 fixed dp of c1. Okay, I think it's, yeah, it doesn't actually matter, because at this instant we can use small c1 c2 or capital c1 c2 c3, and then return 0. We can also like still like space optimize it, okay, like using, which obviously I'm not going to do, because I'll go crazy over that. I'll just like this is previous one, and dp of c3 is equal to current one. So I think like that's it mostly for this question. So okay, so let's try to submit this. Okay, these ones are actually a bit tough. Right? That's why I was saving them for the end. Okay, 3 hours almost going to be there. Okay, so I guess this one will also get submitted. Now we have how many questions left to do for today? We have to do matching, then digit sum and permutation. Matching this question is on based on what? Bit masking. This is a very nice question. This will give you a bit introduction of bit masking. Generally, you can like first I'll explain you the basic approach. 1 second. MNO tasks. Independent set matching class. Okay. Okay. So where is the question? Yes. So first we are going to approach this. Like I'll tell you like the basic approach how to solve this question. If we run this, probably that's not going to work. But still, we are going to do that. Like it's just like an n queen problem, right? We have to find like a number of ways in which tarot can make pairs. We have given a compatibility matrix, right? So like if a of I j is equal to 1, then they are compatible. We have to print it modulo 10 raised power 9 plus 7, right? Constant end. First, I'll give you a basic approach so you'll get the idea of how the recursion actually works. Then we'll go to the bit masking version. So basically, we'll create int n, right? We're going to scene n for int I is equal to 0. This is just taking in the matrix values. We'll create a set for women, right? We are going to insert in that set plus plus 22, right? So we are going to insert the woman in the sets. So we can just search which women have been used for compatibility right now, see out. And then we'll create a function f, and that function is going to take the number of men, and obviously initially we have same number of men and women, right? So they can be paired. Insert int, it's see out f of what? Initially we have 0 pairing of men and we have the whole set of women. If m is equal to n, return 1. Like we have reached the end. Like we have paired all the men with n women, right? Initially answer is equal to 0 and we are going to return what? Answer. Right. So like this is the basic approach. Now we'll go to all the women. Like we'll see w is less than n, w plus plus. If we'll see that that woman is available in the set, right? Right, and then a of m w, which is equal to 1, right? Like they are compatible. So what we are going to do, we are going to erase that woman from the set. This is like the basics recursion method which you do, and then we are going to answer plus equal to, we'll go to other states, right? that is f of m will go to the next man and then w, and then we come back, we are going to w dot insert this woman again. So this is like the basic recursion method. I don't know if it will like even get submitted or it will give TLE. So like basically this is it. So this is how we like solve this question. Now actually the issue is, even if you memorize it, like using DP, it's still not going to work. It is like n factorial now, right? Yeah, okay, it's giving compilation error for some reason. Huh? Long int previously declared here. अरे हटा दो ना भाई. So I think, yeah, like it will get submitted a bit, but it will get TLA. It has a lot of time complexity. Yeah, right. So now let's go to the bit masking approach. Generally, on seeing the constraint, we should get the idea. Okay, we'll just remove it. We can just like comment it out. Yeah, commenting is also like better. Yeah. So now when you'll see the constraints of this question, we will get to understand that we have to use bitmask DP mostly, like generally, right? So like if you have to pair ith woman with jth men, or ith men with jth woman, so like the pair, both their pairs are going to decrease by 1 values. So let's create f of I comma x, what number of ways to pair men from I up to n with women left in x. X is our set of women, right? Just we created a DP. Now our time complexity will go from n factorial to what? As we will use a bit mask here, so it will be 2 star n. 2 star n is the number of states in the bit mask. N is for men, and for each we have to go through n states, right? I'll explain here. This n is for the DP of men, like there be n states of men, and this 2 raised for n is that bit mask which will be having 2 raised for n states, and this n is for each man will try with all the n women. So that's it. See, our time complexity got improved a lot. Like 2 raised for 21 is still a very small number. So let's do this. We have to okay, let's start. So int n cnn vector of int c of n. This is like compatibility matrix or vector, whatever you want to call. N plus 1. Yeah. Right. So okay, I think it's okay. So where were we? Yeah. One raised for, I think it will be 22, right? I got distracted for a second, my bad. For int I is equal to 1, I is less than equal to n, I plus plus. For int j is equal to 1, j is less than equal to n, j plus plus. We are simply going to say in c of I comma j. That's it. This is the compatibility matrix, and then we'll create a matching function. What it's going to take? The index of the man, the bit mask for the woman, and a vector of a compatibility matrix, and then also a DP matrix, right? That's it. And then we have to just see out what we have to see out. Matching 1 raised power n minus 1, because we want to make all the women currently set. That's why we took 22, because there are 21 women. 1 raised power 22 minus 1, there will be 21 set bits. And see, I think we can make it global. We can also parse whatever, it doesn't actually matter. Yeah, we should make it global. Yeah, like we can also pass, that doesn't even matter, like that's just nonsense. Okay, so let's start. If I is equal to n plus 1, right, which means all men have got some chick, so by chick I mean a woman. If the mask is equal to 0, which means at that time all women have also been, got taken by some men, so we'll return true, like 1, like that's a correct value. Or if the state has already been visited, the mask is equal to what, minus 1, return dp of I mask. That's it. Else whatever answer we are going to get, so we'll create an answer reliever first. We are just going to return dp of I mask, which is equal to answer, right? For int w is equal to 0, w is less than n, w plus plus, just like the same approach, but here we are just doing a bit different. We'll check if that chick is available to be paired with that guy. How we are going to check? If that particular bit is set, just do it like this, like basically to check if that bit is set. If it's this thing, whole thing is equal to 0, which means like it's not available, else it's available. And if it's available and they are compatible, like that guy is compatible with that girl, check. So what we are going to do, simply answer is equal to what, I think mod is also here, right? Answer plus matching of what, I plus 1, and in mask we just like offset that bit using XOR. 1 is for w, comma n, comma c, comma dp. Yes, and then we have to hash mod and hash mod. Okay, so that's it. Okay, I didn't pass it. I here did not. Okay, we have to just constant 8 mod, which is equal to 189 plus 7. Yeah, I think it's mostly right, so let's submit this. So with this you got a basic idea about like bit masking. There is some error. Okay, this is equal to 0, sorry. Okay, yeah, I think this is going to get submitted now, hopefully, and good. Yeah, so how many questions we have done till now? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So we'll just do 2 more questions, like walk we have done. We'll do digit sum and permutation. After that we are going to end this video. Rest 6 questions we will cover in the next tutorial, you can say, right? Okay, so let's go. Digit sum. So before, if you have no idea about digit DP, I'll give you a brief introduction. Like a very brief introduction. Like first we should start with like what? Let's create a function, right? Void function int I int num to just print all the digits. So get like the idea how to do this. Function will start with 0 and 0, right? If let's say I is equal to 3, we are going to see out that num and L, else we are going to return, right? And for int D is equal to 0, that particular digit D is less than equal to what? 9, D plus plus. Fun of I plus 1 num star 10 plus D. I think, yeah, let's run it. I think it is going to keep on printing till 3 digits, yes. I is showing the number of, like 0th index, first index, second index, right? When we reach the third index, we are going to stop and we are going to, yeah, we are going to print that particular value. See, each of these values are going to reach the third index, even the, 99 ones. It will be just 009, right? So what we are doing is, like, this is just basic printing how it goes. Like for each index, we are going to fill it with 9 values. Num star 10 plus D, right? That's it. So this is like basic printing of all the jets. Now what if we want to like print it till a particular value only, right? Like we want to print it till a particular value. How can we modify this? You can say, recurrence. So what we can do, we'll create a void function int I bool, let's say bool flag, right? Int num. Okay, let's comment this out for now. Basically, if I is equal to what, we'll take a string as like as dot size. Same thing, see out. Like we have to print till that particular value. Like string s is having 75 in string form. We have to print till that only, right? So what we'll do, we'll print till the flag is true. Flag is true till when? Like s of I minus 0. You understand what I'm saying with this? If like we are like number is 75, right? Number is 75, right? Like number is 69. If we have I is equal to 6, right? Then there is going to 60, like, yeah, like fuck. If number is like 63, like if we are currently going through all the number in the range 60, like 61 to 3, then there is going to be a constraint. So this is what's happening. If flag is true, right, then this is equal to how much? S of I minus 0 for that particular index minus the character value there. So then what we are going to do, for the same as before, for d is equal to 0, d is less than equal to 9, or rather it's only going to be 9 till d plus plus, right? Function of what? Let's call it f only. Yeah, that's better. See, this is just we are creating a constraint here. I plus 1. See, flag is only going to be true if we are in the 60th range, or when we reach the 60, if the number is bigger, if it is in the 6-3 range, right? So either flag it's already true, and if that digit is equal to what? Till. That's it. Okay, so yeah, and then num star 10 plus d. That's it. Last value, yeah. So flag will only be true for what values? Or s values. That's it. Simple. Now let's try to print this, right? See, let's take a string C in S, right? Let's call a function 0, 1, 0. Like starting from number 0, 1 digit. Okay, it's F. Let's try to run this. So like this will give you like a brief. What is the error? Oh, okay. Wait. Let's call 75 and then we go. It will print till 75. As simple as that. And with this, our question is actually done. Like actually done. If you can understand till here, then this question is done. There's nothing in this question now. I'll just remove this. Well, there are some things, but generally it's mostly completed. 1e9 plus 7, right? Right. We have a string k. See, that's why na, it only matters this 10 raised power 4 is the real value, because we are only going it like how many digits there are going to be. It's that's why we are doing digit dp na. Yeah, and we can't take int as an input, like, yeah, so we have to like string k, right? Int d. I think it's better looking if we brought it down here. Yeah, and then how much number of digits? 10 raised power 4, right? Constant 8 mod is equal to this, n is equal to how much? 1e4. 1e4 number of digits are going to be there. Int dp of n to 100. See what we are having? N number of states, right? N number, or we can say like 10 raised power 4 states. Digits. Okay. Right? 2. 2 is like a flag. True or false. Like if this is like among the S category of numbers or not. And then 100 is for just D. You know, like D. 100 like to see if it is a multiple of D. Okay, we'll do that later. Don't worry about that. Forget about this dp for now. Simply, we're going to do c and k d. That's it. And we are going to like dp. We are going to put it by memset dp of -1 comma size of dp. Yeah, that's it. And then we'll create a solve function. Let's call it int f, which is going to solve int I bool last flag. That's it. What we're going to do, if I is equal to what, like we earlier did, k dot size, return what? If I is equal to k dot what, will return 0. Currently it is 0. Okay? We are not taking into account the sum of its digits in base 10 is a multiple of d. We'll do that later, right? So simply if we are going to, if dp of I, dp we are not even having right now. Forget about the dp. Similarly, int answer is equal to 0, right? And flag is equal to what? If no, till value is equal to what? If flag it's true, right? And then k of I minus 0, else it's going to be 9 normally. That's it. Now for int d is equal to 0, d is less than equal to till d plus plus. answer plus equal to dp of I plus 1 last and then last value, or like flag value, whatever, you can take both digits, like d is equal to tail, right? That's it. And then answer equal to mod. So generally this is how we did the previous questions, right? Don't worry about this. Now the thing is, we just have to like get one more variable here, like one more part. The sum of the digits in base 10 is a multiple of d. So simply whenever we go to a new digit, we just take its mod. That's it. So simply like that. Just like that, question is done. Just we pass in another function, int modulus, and when we go to a new digit, we are just going to add the mod plus that digit, mod 10, mod d, and that mod is going to be always less than equal to 100. And if we return, if when we reach the like complete the string, if mod is equal to 0, that's it. And we just have to like memorize it also. If dp of I flag mod, like which is not equal to what, -1, then we are going to return dp of I flag mod. Basic question, and here it's going to be solved, right? And return dp of I flag mod, which is equal to answer. That's it. And then we call the function. We are just printing. Here we just add one another condition. So like step by step you have to do. For just able to print everyone, then able to print everyone with till a limit, then able to print everyone till a limit, but with some constraint. And just we have to like see out what dp of, you have to form like, we start from like 0, right? I think k is greater than equal to 1. So we have to like just subtract 1. Yeah, right. -1. See, as it's -1, right? Right. So our answer, I think, maybe can be negative or not. I don't know properly. Let's see if it's working first. Yeah. Okay, how we are getting a compilation error? Solve. Yeah. Like generally it's. Oh. Okay, so this one is okay. Okay. This one is how it's not right. If I is equal to k dot size, I think I'll just add like brackets here. Yeah. I think I just have to add the brackets. Maybe that will solve the issue. If not, then we have to see what is the issue. Okay, it's still giving error. Okay, so let's see what is the issue here. Like we're taking the input, right? We memorize it -1. Yeah, yes. Okay. Okay, let's try this once. I don't think it will create much of a difference, but yes. Okay. So dp of n 200 n is equal to 1e4, exactly 1e9 plus 7. I is equal to k dot size, we are going to return mod is equivalent to 0. Okay, if dp of I flag mod is not equal to -1, we are going to return. In the end, we return answer. Till is equal to last flag k of I minus 0, else 9. Oh, okay. Okay, this is okay. This is like overloading D and D. So let's call it digits. So this was the issue actually. Okay, now I think this will be working. Let's just change this to DigitSum. Now what about that? Okay, while this happens, let's go. I think it will get submitted, hopefully. Okay, okay, this is a GitHub link. Now that I was talking you about the lower bound solution, right? For the flowers question. Okay, it's still giving error. Okay, first we'll sort that. What error it's giving? RE is runtime error, right? So we have a string k in D, constant in mod is equal to 189 plus 7. Okay, that is good. N is equal to 1e4, that's also working. We created the right DP state n 2 and 100, right? We created int k and d memset dp of -1. This is right. We'll solve the function from 0 1 -1 exactly. If I is equal to k dot size, return mod is equal to 0. If dp of flag is not equal to -1, we are going to return that answer is equal till flag is equal to k of I minus 0, else it's going to be 9. Digits equal to 0, digits less than equal to till this, answer this equal to mod. I think it should work. There is no reason for it to not work, but I don't know what is the issue here now. How could it not work? Like, everything is correct. How it's giving runtime error? Uh, okay, simply let's do this here. Like, int n is equal to k dot size. If I is equal to n, I don't know what's this. Mm, or maybe okay. Why it's showing runtime error? Just give me a minute. Can I pause the video? Okay, so I see the issue. Like, we are having the same naming right here. So I think that's the issue. Like, for D, what we had the problem, I think we are having the same problem here. So let's try to submit this now. Hopefully it will get submitted now. Yeah. And this is for the flowers problem. Yeah. And then just one question is going to be left, which is permutations. Okay, it's still giving like how it's impossible. Okay, this mode we have to change. It's actually yeah. So now it will get submitted. Yeah, good. So where was I? This flowers question was also done this like in the previous video, which like had some issues, so it wasn't working properly. I solved this using this lower bound method. I'll just give a brief intro so that nothing is actually left. I don't actually have the energy to write it now. We just get a struct for height and like beauty. Then what we want to create a DP of Excel store the maximum beauty which can be formed till this index, right? First, like we'll create a map of height and DP. DP of 1 is obviously going to be its beauty, right? And then we are going to in the map put that value. Answer currently is equal to DP of 1. We'll just maximize the value. Now we'll go through all the values, right? DP of I is equal to A of I comma B. Like each and every DP will at least have that much beauty, right? Then we are going to found the lower bound for it, right? Whatever lower bound it's going to be there plus 1, right? So we get that particular index. We are going to do IT minus minus because we have already did plus 1. And to this particular index, we are going to add the second value of the beauty of that value. Okay? Like this is such that like we get the maximum DP. We add the maximum DP of all the smaller heights. Now we can use this DP value to eliminate higher heights ones with lower DP because we are not gonna use them. And then in the map we are going to put this value, and then after this we are going to delete all the values with more height and less DP. So we are going to use an upper bound function, and we are going to go till the end of the map. And if the DP value is smaller than the current value, we are not going to need it. We are just going to erase it. And with that, we are going to maximize our answer. And this was the flowers question. Yeah. And with this will be our last question, and this is also a very good question, like very good question. Permutation. So we have done around 19 questions, and it took us solid like 3.5 hours. In this question, like 10-15 minutes, like total 4 hours. So next 6 questions are going to be in the next video probably. Yeah, so that's it. Let's start with this question. We are given a n positive integer, right? You're given a string of length n minus 1 consisting of greater than and less than. So we have to find the permutation p1 up to pn of 1 up to n satisfying the following condition, right? So modulo 10 is for 9 plus 7. Yeah. Oh, okay, so uh, like see, like like we have given 1, 2, 3, 4. Like if we are given less than, greater than, less than, greater than, right? Like whatever value we can fill in the next index depends on how many elements are, like if this sign, how many elements are smaller than this and how many elements are greater than this. So we have to keep that in point. Okay. Yeah. So let's say that like if we are having some slots like this, less whatever the sign, we don't actually care about the sign now, just the slots for now, right? Whatever index we fill here, right? For this index, we should know how many, we should keep track of how many are smaller than it or how many are greater than it, right? So what we'll do for a particular index, let's create S. S is the numbers which are smaller than the number which I have filled. Okay, that's it. And G is the numbers which are greater what than the numbers I have filled. But if we are at some index, you can say I, then we have already used I numbers. So S plus I is always equal to N minus I, right? Unused elements in the set. Okay, unused elements in the set. Okay, so now what? Now to go through this, right? Like for if we have like for what case, like if we take let's say we have a set of S comma G. If we take a value such that it's a greater value, right? So the set is going to become S of G, S comma G minus 1. Else if we take a value which is also greater, but it in that set it is the next greatest, so it will become S plus 1 G minus 2. Let me explain what I just said. Maybe it might be a bit confusing. It's like the best question of all of these, so I fill it in that. If you have 1, 2, 3, and 4, right? Currently, in the last position, like in a slot, we fill 2, right? It has a set 1, comma 3, 4. It has a set 1, comma 2. Like one element is smaller and two elements are bigger, right? Like this. If in the next slot, let us assume we have a smaller sign. Now, if we fill 3 here, then the set is going to become 1, comma, you can say 2, right? But if we filled 4 here, right, the set is going to become what? 1, no, 2, comma 1. Because now we have two smaller elements than this current element, right? So like this is just the basis of the recurrence which we are going to form. For the smaller case, we are going to put a greater element, right? So dp of I plus 1, comma s, comma g. But we don't need to take both the variables s and g, because obviously like s plus g is a constant sum depending on n and I. So which is equal to how much? dp of I plus 1 s plus 1, right? Up to how much? dp of I plus 1 s plus g minus 1. Okay, so you got the answer, right? Because we can put any of the greater elements here, right? How many? G minus 1 elements, like the last element, right? Similarly, for the smaller case, dp of या तो we took the smallest element like 0, there's nothing left, or we took dp of I plus 1, comma 1, or we took like this dp of I plus 1 s minus 1. Yeah, that's it. So our value depends on the prefix sum, right? Yeah. So yeah. Now still, even if we like optimize it to 2D DP, right? Like just have I and I s and I as an constraint. Still, we have to doing the same thing like before. Like remember in the one of the previous question, whichever it was where I told about like recurrence manipulation. Like I told like either we can do it using prefix sum or using this, right? So first we'll solve it normally, right? I'll also show you how to solve it normally, so you'll understand what I'm trying to say. Int n string str, right? Str int, let's say solve, right? Solving index and s. and then I will create a vector of int of dp. I'll also show you by both methods. Obviously I'm doing vector of int of mxn, which I have not made yet. I'll make that constant. Obviously there is going to be a modulus value, right? Along with that we'll also put mxn. How much? It's like 3k, right? So mxn, which is equal to 3e3 3 plus 3. Yeah, like kind of funny. So yeah, that's it. Now we are going to take this string as an input, scene and seeing string, and after that int answer is equal to 0. For int I is equal to 1, I is less than equal to n, I plus answer plus equal to how much? Solve of all the 1 up to I minus 1. That's it. Like whichever value we put, right? We can put any value at the first index, right? Whichever is going to give us the answer. So we are simply going to see out the answer mod, and then now we'll just we have to, like, this is basic recurrence. We are just passing in all the, for particular index we can have all the I minus 1 values, right? Like 0 up to n minus 1. Like this is the index. So simply if like we reach the end, right, if I is equal to n, right, we are going to return 1. So if dp of I s is not equal to minus 1, return dp of I s, right? Int answer is equal to 0. We just have to return dp of I s is equal to answer, right? And then if str of I minus 1, right, is equal to what? It's a smaller than sign. What we have the smaller than this case, right? So for int j is equal to 1, j is less than equal to how much? N minus g. And how much is g? I minus s, j plus plus. Answer is equal to dp of I plus 1, s plus j minus 1, right? Call g is equal to how much? N minus I minus s. Else for int second case, it will go up to 0 to s minus 1. J is equal to 1, j is less than equal to s, j plus plus. Answer plus equal to dp of instead of dp we have to solve here, like, yes. So yeah. So basically this is like the first part. It is obviously going to give us TLE. We have to like optimize it, but first we'll see it. Like this is like the one of the best questions in here till now. Obviously the next 6 are going to be more difficult. So it's giving wrong answer, or okay, it should at least give like a right answer for some of them, no? So I can say like it is giving TLE, but it's giving wrong answer. So let's check why our, like, unoptimized solution is not working. Solve if I is equal to un, return 1, dpi will return answer equal to 0 if for int j is equal to 1, j is less than equal to n minus I minus s. Answer is equal to solve of I plus 1, s plus j minus 1, j minus 1. So like overall you get the idea, na? Like this is like the unoptimized approach. There might be some issue here in which it's not working because we have 2 states, right? And with that we are also having a loop to traverse in between, right? So that is like increasing a lot of our time complexity. Okay, yeah, so it did work for two values. Yeah. So what we can do, we already optimized it, but n cube it's still giving TLE, like it will give TLE. So we can see that n cube, because we have to traverse in this loop also. So our value depends on prefix sum of next dp value. Okay, so yeah, that's it. As you can see, it just depends on the prefix sum of the next dp value. So instead of starting from the 0, if we start from the reverse, right, if we start from the end index, like fill from the end, then we can use that particular row to fill the previous row. Like, see, like such an amazing question it is. So I'll just comment all of this out first. Yeah, like the best one question here in this problem set till now. Okay, so it's like the tabulation bottom up approach, like tabulation approach. Tabulation approach along with recurrence manipulation using prefix sums of dp. Okay, int answer is equal to 0, int dp of, okay, you can just keep this much. Okay, int dp of n plus 1, right, mem set it to 0, because we are doing tabulation, not memoization. dp of what, if we reach the last index, right, and no smaller elements are left, then then it's simply going to be 1, right? Yeah, if we reach last index, right, and no smaller, then what we do is we fill from the last row, so it can be used in the prefix sums. And j is equal to 1. We are calculating prefix sum, and see, such an amazing question, right? We are going to calculate prefix sums of dp in that dp area, right? Calculate like for the next row, dp of I comma j plus equal to dp of I plus 1 j minus 1. That's it. We have the prefix sums. Now we'll go for int is is equal to 0. We'll just now fill the table, right? And like int g is equal to how much? G is equal to n minus I minus s. Now g can also get negative, right? Because like obviously if some particular value, like it can get negative. If g is less than 0, obviously we are going to continue. In tabulation it could go negative. Now we'll apply the same loop which above apply if this is a smaller value, right? So dp of I s, which is equal to how much? dp of I plus 1 s plus g minus 1, right? Minus how much value? If s is equal to 0, right, then it's 0, else dp of I plus 1 s minus 1. Yeah, as s minus 1 can be negative, else dp of I s equal to dp of I plus 1. We can have a separate prefix sum, but we don't need to do that. So s equal to mod. That's it. And when this loop ends, we'll just for int I is equal to 1, I less than equal to n I plus plus. Yes. Okay, yeah, one more thing is we go till here 1, because if you go here by 0, it is going to end up modifying the 1th row, which we don't want. Okay, because our answer is going to come from that row only, right? If I find the prefix sum for that also, yeah, so like that's going to cause problem. So yeah, and it can also go negative, like we are subtracting, so we are going to do answer plus equal to mod answer equal to mod cout answer, and then I think we have not, we don't have the mod only. No, we have the mod only. So I think if this gets submitted, hopefully this will get submitted, and with this we'll finally end the video. Okay, obviously it's not going to get submitted. So like currently, like what is happening, TP n plus n, yeah, that's right. We mem set dp of n0 is equal to 1. If we reach rat index, no smaller elements are left, right? This loop will go I to n, answer plus equal to dp of 1 I minus 1 mod. This is see, answer plus equal to mod, answer mod equal to n. This is right. Right. Now we're going from the n minus 1th row till I is equal to 1th row, right? For j is equal to 1, j is less than equal to n, j plus plus, dp of I plus n j plus equal to dp of I plus n j minus n. For int s equal to 0, s is less than equal to 1, in g is equal to how much? N minus I minus s. If g is less than 0, continue. If string is equal to I, dp of is dp of I plus 1, s plus g minus n minus what? 0. Okay, so okay, what is wrong here? Like, yeah, well, the order of the loops is actually correct. What is the error actually? Let's try submitting this again. Like T-Permutation. Like, let's see. Also, I think it's going to be the same one as this one. So, okay, there are no right answers actually. There are no right answers. So, what is the issue that is here? Okay, if string, oh yeah, fuck. A string of s minus 1, yes. And with this, over 20 questions are completed, and at exactly 5 a.m. Okay, so actually, okay, fuck. Like, come on, man. Like still questions are wrong. Like, how it's, if string of I minus 1 is equal to this, dp of I is equal to dp of I plus 1, s plus g minus 1 minus s equal to 0, exactly. Hey, is it like actually not working? Yet how it's not working? Arey, bye, like, fuck, man, like, actually, fuck, like, fuck me. And with this, our 20 questions are finally complete in 3 hours 50 minutes. Finally, yes. Okay. So I think we have completed, right? All 20 questions. Frog. So this, like, I'll give a brief outro of all the questions. So this was like basic, like Fibonacci type question. This was just like Frog 2 was another version of it. Just we have like case states instead of one. In vacation, we can like this was just like we can reach to two states from one of them. Like we'll try to see which is the best in the end. And where's the F-LCS? This is just longest common subsequence, printing of longest common subsequence. And this was the longest part. This was just basic DFS. Yeah, it was just actually this much question. Like rest is just writing the question. And then this is grid. Here I explain to you. We can actually see like what is the issue here, but I am not in any or time now. So this was like basic, like to tell the idea about like indexing does not matter that much. This was coins question. This was basic probability question regarding probability. And this was okay. So if opening now again and again, so M-Candies. This was a very good question. It was like for recurrence manipulation and slimes. So this was also very good question. A partition DP, a very good question, but starting from the end instead of the first. DQ, this was a very nice question. Actually, a very good question. We are like an independent set. This was a very easy question. Yeah. Flowers, with segmentary, it's actually very easy. Like the other approach is actually a bit complicated comparatively. And keystones, yeah, this was very easy. The basic game theory question. And like knapsack one is very easy. I just did using space optimization. And knapsack 2, it's a very nice question. Like it's a variation, like very good variation. And these are all like the dangerous questions which I left. Sushi, it was probability. Implementation is also very good here. Matching, it gave the idea about bit masking. It's like very basic, good bit masking question. With R, it was like just matrix multiplication in dynamic programming. Okay, that's it. So, and this is digit sum. Yeah. And yeah, this was a digit sum one. It was just bit of you know digit DP type question. It's actually good. Permutation one this is like the best of all the questions till now. And I have like how many questions left till now? Grouping, subtree, intervals, tower. I'll probably solve them in the next video as it's already 4 hours. So actually today is my birthday and I actually wanted to put at least like most of the AtCoder problems before my birthday. So like solving them on the birthday I think still counts as like before birthday finishes. So overall now we'll have like how many problems left? Grouping, this I have to look in. It's actually bit I can actually do it still now. Like it's also DP of bit masking, but I'll keep it for the next video. It has been 4 hours and it's like 5 a.m. in the morning. So this is going to be a bit mask question. And this is going to be some graph and this question. Yeah, and intervals. Yeah, I'll look into these later for the next video. Overall, it was a very nice tasks. Tower and this grid 2, it's going to be a convex cell optimization problem. Like for that, like have a good idea about convex cell and advanced DP techniques. Or also like there's a lot to learn from this question, like space optimization, tabulation, basic recursion, memoization, uh, coins probability, bit masking, bit digit DP, and recurrence manipulation, segment tree with this upper bound, lower bound. So overall, it was a very nice productive video. If you made it till here, like do like, comment, and subscribe. It took a lot of hard work to actually make this video. I was actually very feeling very sleepy. Like I actually wanted to sleep and make video maybe tomorrow or next week, but sometimes we got to do stuff. Okay. Okay, and with this, thank you so much. Like, share, subscribe.